Okay, good morning again to everyone. Okay, so this week and next week, you will be looking at this modules, text analytics. All right. Okay, so my name is Gan. You can call me Gan lah. Okay, yeah. So the the schedule for today, you can find it at the e-learning page. Okay, so this is the schedule for today lah. Okay. So in a short while, I will brief you through the materials. Okay, after that, you can take your entry assessment, okay, quiz in this page as well. So you can spend around 30 minutes on the quiz, okay, as well as one this ice-breaking activity. Okay, so we will start at 9:40 a.m. Okay. Okay, so around 9:40, we will go through one very simple overview of what is text analytics. Okay, so I will just introduce the some techniques that we are going to actually practice it in the afternoon session. Okay, so we will look at some fundamentals, and then after that, we will start with the hands-on. Okay, so the hands-on part, we will be using R. Okay, so there are a few parts. Okay, so we will start off with basic like data loading. Okay, and then after that, some text preprocessing, and followed by the some text analysis. Okay, at the end of the day. Okay, yeah. So that is for today. Okay. So at your end, you may download the software first. Okay, so yeah, so for R, you can download the R software from this link, and also R Studio. Okay, so we will be needing these two. I will show you again. Okay, so for this and this. For the packages, we will go through together how to install the packages. Okay. So down here, there are the materials. Okay, so these are the materials that you can download. Okay, yeah, for your class and reference. See, these are the materials and some scripts. Okay, data sets and a book. Okay, so that's all the materials for today. So we will be using a Padlet as well. Okay, so there's a Padlet. You can click on this link. So are you able to access this page? Are you able to access, can you see this page at your end? All right, good. Okay. Yeah, you may open up the Padlet as well. So we have a Padlet. Okay, we have a Padlet. Let me share the activities. Okay, just to show you where is the assessment. So it's down here. Okay, so you just scroll to the end of the page. Later, at the 9:10, you can start the doing the quiz lah. Okay, yeah, you can take around 30 minutes to do that. Okay. So this is where the assessment is. Okay, so this is some introductions about this module. Okay, let me share okay, another slide. Okay, let me unshare first. Okay, can you see the slide? All So we will start off with this activity, okay? So this module is text analytics. I think this is your second last module, right? Yeah, after this you will be having one more module, and then you can proceed with your project. Okay, so this is your second last module lah. So our first activity is to post your a photo, okay, a photo of your favorite tourism spot in Malaysia. Okay, yeah. So the scope is Malaysia lah. Yeah, you any tourism spot that you like. Okay, you can just post a photo of it in the Padlet, and also in the post, right? Yeah, just write down your nicknames or your name, okay, so that we know who you are. Okay. So that's our first activity. And then in a short while, at 9:10 a.m., you can start your pre-training assessment. Okay, at 9:10 a.m., you can start your pre-training assessment. Okay, so you can do both of these activities for 30 minutes. Then at 9:40, we will start the training. Okay, yeah. Do you have any questions? So just a quick check lah. Maybe are you able to access the Padlet? Yeah, are you able to access the Padlet? Okay. So maybe one of you can try to post something, yeah, at the Padlet. Yeah, things should be accessible. Yeah. So you can try to post, and then 9:10 you can start your pre-training assessment. Let me share this full screen. Okay. Share screen. Yeah. So this is the Padlet. Okay. So you can start doing the posting. Yeah, you can post your the favorite tourism spots in Malaysia, and then write your name. After that, followed by the assessment. Okay, so after that, you continue to attend the quiz down here. Okay, so there's 10 questions. Yeah, so you attend the quiz over here. And after that, you may download all the materials. Okay, you may download all the materials. Yeah, just put in one folder. Okay, so I'll show you which one to use. Yeah, as we reach that section. You can also download R. Okay, yeah, R is here. So you just go to this link, and this is the R package that you need to download this. So you just follow the operating systems that you are using. Okay, so if you for Windows, you can click this link, and you can just install. If it's for the first time, you just click here. Okay, yeah. So basically, you just need to install the this one. Okay, you can get the latest version, which is this. Okay, so another one will be R Studio. Okay, so R Studio, it will bring you to this page. For R, yeah, this is the same link for R. Okay, download and install R, the same thing, but you can come here on the right side. So install R, download R Studio. Okay, and you can install it as well. Yeah, this one. Okay, so two activities lah, okay, for you to do, okay, plus the installation, plus the downloadings. Okay, very nice. Wow, many photos. So later you guys can enjoy the photo as well. Yeah. So I just switch back to this page for a while, okay, just in case there are still students joining in. Okay, so I'll see you in a short while, okay, while you just carry out this activity. So I'll see you at 9:40, okay? See you in a short while. Okay, welcome back. Okay, everyone. So, yeah, just let me go through the schedule for today again. Okay, because I think there are some just joined the session. So, yeah, I also introduce myself again lah. Okay, so my name is Gan Keng Hoon. So I will be your trainer for this module, which is this week and next week. Okay, yeah. So I think same as other instructors. I'm also a lecturer from the School of Computer Sciences, USM. Okay. Okay. So you have done the post. Yeah, I've seen that in just now. You can see that. Go back to the pattern in a short while. And also you have yeah, you can still continue with the entry assessment. Okay, if you haven't done that yet, yeah, you can continue with that. And okay, we are going to start with the fundamental in a short while, then followed by other hands-on module. So in between, we will take breaks. Okay. So these are the materials that you can download. Okay, for first, you can download everything and place them in a folder first. Yeah. Okay, there's a message. All right. All right, sure. Yeah. Okay. In case you have any question, you can just send the message to the chat box. Okay. Okay, so let's take a look at the what is about the text analytics. So prior to this class, have you has anyone in the in this class like deal with text before? Have you done any like analysis using any software, yeah, on text before? Yeah, you can respond at the chat box. Okay, so yeah, you can just type your response. So usually what is JMP? Yeah, is it a short form for something? Oh, it's a software. Okay. Okay, so actually there are different type of softwares or online tools um, that you can actually use to process text. Yeah, I think for text nowadays, like yeah, it's getting more and more common. Yeah, compared to the past, like maybe 10 years or 20 years lah. Yeah. So recently, you can actually see like there are many tools that you can use via various platforms. Yeah. And but then if you are using those tools at the platform, normally there could be some free version for you to try out. And I think normally you will need to make some payment, okay, or subscribe, yeah, to use certain features. So what we are going to do today is we are going to use the open source libraries R, or you can think of it as a programming language. It's also a tools, okay, that you can actually build. Yeah, so it's open source and you can basically download the platform and then you can download the packages related to text. Okay, so there are many packages. Yeah, we are going to look at use a few packages lah. Okay, so but there are many out there that you can explore later. Okay. So once you have downloaded the packages, you can use the functions, okay, available from those packages to do to perform text processing. Okay. So I think if you have used the internet or if you have deal with some paperwork right at your workplace, I think we're actually seeing like a large number of texts. Okay, yeah, and if you look at the social media itself, okay, so every day we also like have to use social media, to communicate with people. You're reading news, you're reading posts by your friends, posts by a certain company, okay, to promote their products, and also the chats between people, okay, in the media. Yeah, so by looking at social media alone, right, the amount of text is actually a lot, okay? Yeah, a lot. Yeah, because people keep on like generating text, okay? They comment, they type, discuss. So these are one big part of text, okay? Yeah, that we can actually find from social media. Okay, so apart from that, text also appears somewhere else, like documents, okay? Documents, books, articles. Yeah, so basically, if you like to work on textual data, there are many different types of text um, from different domain, okay? From different domain. But then it goes back to the problems that we want to look at. Yeah. So given like a large amount of text, or even just one piece of text, like one long article, okay? Yeah. What do we want to do, or what do we want to get from the text? Okay. Yeah. So normally, if you want to analyze the text or to process the text before even we start processing, okay? You need to have a purpose lah, okay? You need to have a purpose. Why do you want to process this piece of text? Okay, what do you want to get from it? Okay, so let's say you are reading a long review article, okay, very long review article. Okay, so normally what do we wish for when you are reading a long review article? Okay, you may think of like, can I get a summary version of this long review instead? Okay, or can I straight away go to some points that I need to know? Okay, yeah, because it's so long. If I need to read everything line by line, word by word, it's going to take time. Okay, so is there a way for us to like just get the key points that I should take note? Yeah. So if there's such a goal like this, right, or there's such a purpose like this, then we can start thinking about how to reach the goal. Okay. Yeah. So that's when we start designing the pipeline to achieve the goal. Yeah. So that's where the different processing and the different analysis parts come in. Okay. So if you compare the uh, text text data, okay, and the uh, numerical data, for example, generated by some devices. Okay, so textual data, we often say that it's semantically rich. Okay, semantically rich. Okay, here, semantically rich. Okay. So what does it mean by semantically rich? Is the content itself, it carries meaning. Okay, and then the meaning is is very creative. Okay, it's very creative. You can express, like if a same piece of information, for example, using different sentences. Okay, yeah, same piece of information. Yeah, or you can write even one small piece of uh, info using many different ways. Okay, so that's why when you look at text, right, we try to understand it, it's more challenging, okay, compared to for example, a numerical data, a categorical data. Okay, yeah. If you see a numbers generated, for example, from a device like a temperature, okay, so we can actually easily interpret, okay, this number will reflect maybe the what is the degree, okay, of the temperature. So we directly can interpret it, yeah, correctly lah. Okay, so when it comes to text data, we are dealing with sentence, okay, we are dealing with phrases, words, and then paragraph. So as the text getting longer, there are actually a lot of this challenge in terms of interpretations. So the longer you get, like if you are reading the whole paragraph, we actually has the opportunity lah, actually to access to the full context, perhaps, okay, yeah, of the text. Yeah, of course that also comes the challenge of how we can connect all these words together. How can we make the computers like to understand uh, these words come after next, and then one sentence come after next sentence, and they are actually connected and they mean something. Yeah, okay. So if we can process or analyze the text well, we can actually get information from there. Okay, so that is our goal. We want to get a better presented information. We also try to get some knowledge. Okay, we try to maybe get the patterns, try to see what it's trying to tell us. Okay, yeah. So that's where the AI comes in. So what is text analytics? Okay, yeah. So basically, we can interpret the analytics as how can we make the textual data, okay, which is in natural language form. Okay, yeah, because when you want to express a piece of text, right, you will need language, okay, human language. Yeah, so not mathematical language or Pythons or programming language. Yeah, so we are using natural language. Okay. And if you look at natural language itself, right, this natural language, again, we can have different type of languages. Okay, yeah, now we are using English. Um, there are other languages like Malay, Chinese, um, Japanese, Koreans, yeah, so forth lah, yeah, Tamil, yeah. So then we are actually dealing with the language challenge. Okay, yeah. So for the text analytics parts, we are actually looking forward to turn this natural language text into informations and knowledge. Okay, so what is the difference between information and knowledge? Okay, so information, I think we are looking at the presentations. Yeah, if you have a lot of like reviews, is there a way for us to present the review better? Okay, yeah. So let's say one day, like we go to Shopee, okay, we go to Shopee, we browse the one of the product, okay, if you want to buy one of the product lah, okay, yeah. So there are a lot of things there like in the Shopee. Every product, people will have some comments under it, right? Yeah. So yeah, maybe can you give me some example? What are the products that you normally look at in either the shopping platform like Shopee or Lazada? You know, what are the products? And what do people normally comment under each product? Have you ever buy anything? Yeah. Okay, penghantaran laju. So that is one of the comments, yeah, Akmal. Normally, normally there are two types of feedbacks lah. One is the stars lah. We know the rating, like 1 star, 2 star, 3 star. That you can give a stars easily. Okay, that's one of the feedback also. Yeah, and then the other one, you can write something. Okay, you can write something. You can also attach image. You can also attach video, right? Yeah. So when you attach, like if you write something, that is the textual part that the machine can process. So very often you will get feedback like what? Yeah, penghantaran laju, yeah, correct. Terbaik and secure package, don't buy. Yeah, a lot of things. Yeah, I think if you look at the uh, comments from the shopping platforms, they are actually not that long. Okay, not that long. Yeah. Okay, maybe someone to make a complaint, then they will type longer. Yeah. So it is rather short lah, or I think the most it will have like a few sentences lah. Yeah, it will have a few sentences only. Yeah. So let's say if you have yeah, you're looking at one product, okay, and then um reading the review, there are so many reviews, okay, the product may be very popular, there are hundreds or thousands of review. Yeah, is there a way of how we can minimize the reading effort? Okay, yeah, so is there a summary that we can get about whether buy or don't buy, or how can these reviews be presented in a more presentable form? Okay, you can you just think about it. Okay, yeah, if you are a data scientist, let's say for this shopping platform, how are you going to make the information's presentation better? Okay, yeah. And if you think, okay, next level, if you look at knowledge, right? Knowledge, we are actually looking for something that has a intelligent component in it. Okay. So giving so many reviews, some say buy, some say don't buy. So in the end, should we buy or don't buy? Okay, yeah. So at knowledge level, we are actually looking forward to maybe a suggestions lah. Yeah, maybe the system doesn't decide for us, but we can have like we can get a suggestions. Okay, yeah, whether is this, let's say, is this product good or not? Okay, yeah. So that's where the AI related methods come in. For example, you can use we can perform, for example, a classifications to classify whether should I buy this product or not. Okay, yeah, or maybe a certain aspects of this product, is it good or not? Okay, yeah. So that will involve certain intelligence components where you can use methods like machine learning, okay, to learn from the text, okay, to learn what has the text has been saying, okay, whether buy, don't buy, and then it has to be, for example, if you use a supervised method, then the text has to be there should be pre-labeled text for us to train the model. Okay. Then in turn we can use the model later. Yeah. So that is about knowledge. Okay. How can we get something a reference to make a decision if you are given so much text? So if you compare the textual data and the structured data, okay, up there, yeah. So textual data is expressed by human, okay, expressed by human, yeah. But if okay, I think nowadays you can also get textual data expressed by the ChatGPT, right? What do you think about that? Yeah, textual data expressed by ChatGPT. Yeah, because okay, structured data like temperatures, those like measurements, readings, you have device like let's say sensors, then it generates the data for you, and then we analyze the data. Okay, so textual data written by human. Okay, and also yeah, you can get the textual data generated by the ChatGPT kind of language model. But again, the language model, how it generates the text, it also learns by the input lah. Okay, it learns from the input. The input, I guess, could be flexible now because the inputs. Okay, let's say the language model were to learn from many inputs. They need to learn from a lot of data. The data can be written by human, expressed by human. Eventually, one day, the data also is like generated by the GPT. Okay, yeah. So GPT generate data, then it goes back to the language model. That cycle look back. Yeah, it's also possible. Yeah, but yeah, how the text is expressed is actually, even though it's written by human. Okay, now we are writing something, right? There are certain rules lah. There are certain rules when you want to express a piece of text. You need to follow the language rules. Okay, we cannot simply write. Otherwise, if you are talking about formal text lah, we cannot simply write in any structure that we like. Okay, you have to follow a certain language rules. If you are writing in BM, there's a way of constructing the sentence. Okay, there are vocabulary that you need to follow. Okay, then yeah, that is the language rules. Then about what to write. Okay, the contents that will depends on the size of vocabulary of that language, the situations, the event you deal with, and what you want to talk about. Okay, yeah. But then if you combine all these, the output is actually very beautiful. Yeah, normally you can write a very nice essay. Yeah, or very formal one like the report. Okay. So that is how text is generated. That actually relates back to the processing tools that we are designing. Yeah. How machine can process a text, it actually need to be able to um, um, go back to the fundamental. Yeah. So let's say text is made up of words. So machine will need to be able to identify words from the text. Yeah. So it's like a reverse back. Yeah. So when human, like when us, we write a sentence. Okay. The sentence is let's say very long. Machine will need to be able to interpret what this sentence is about. So at the very base level, machine can actually look at what are the words this person is using. Okay, it can also try to see the vocabulary. Okay, yeah, which one is word, which one is not a word. Okay, and then what are the vocabulary used, is it correct or not? Okay, and how the sentence at the higher level, how the sentence is constructed. Okay, that's where the parser come in, the NLP parser. Yeah. So that is reverse back. Okay, when machine try to understand the text, it need to get the text as input and then try to reverse back to the language structure. Yeah. So that's how the machines can again collect back the informations, and we'll see what we want to do with that lah. Okay. Yeah. It can pump into the language model and generate some things. We can store, we can do calculations, countings. Yeah. Okay, so that's the difference okay, between what we can do with a piece of text expressed by a human compared to a structured data. Okay, okay, so next one. Yeah. So there are different type of contents, okay, that we can produce. Yeah. You see, like in the same event, right? Like just COVID pandemic, different type of textual contents can be produced. Yeah. So actually depends on the task lah. Yeah, what these people, what these individuals need to produce. Yeah, so we can have like scientific articles. You will see scientific articles, right, from COVID. Yeah, and then news guidelines. You can see new laws coming out, and a lot of social media posts. Yeah. So this is where we are actually getting all these textual sources. Okay. So when you have this, so that's where the text analytics come in. What you can do with this. So for example, social media posts. Okay, social media posts. If a company or the governments would like to know what is the sentiments, okay, among the people from the social media post, then we can perform the analysis on the sentiments. Okay, and where does the sentiments come from? How can we get the sentiments? The sentiments actually expressed in the words by these people. Okay, yeah, people say no good, that means a negative sentiment. Yeah, or people say don't go for the vaccine, then maybe it could be negative lah. Okay, yeah, or there are something like yeah, I mean, so the sentiments depends lah. Okay, depends yeah, how we define it. Yeah. So in the end, we can actually present a summary lah, for example, like this. Okay, a chart like this expressing the sentiments of people. And there are also, for example, cases like fake WhatsApp posts or fake posts that you are seeing maybe in Facebook or news, circulating around. Yeah. So how do we know that this is fake or true? Okay. Yeah. So one of the analysis that can be performed on the text is to predict, okay, whether this text is genuine one or fake one. Yeah. So that's where the machine learning comes in. We can predict and then quickly can sort out lah, or you can alert someone lah, okay, that this is actually a fake one. Yeah. So even with news, if you are looking at like COVID news, there's a lot of news being released in various news platforms. And when the number of news grow, right, from day to day, from month to month, so this news also need a better way of like summary, via summary or via some category, yeah, categorization, so that we can actually look up the news easily. Yeah. So that's where this is the part where the analytics can take place. So yeah, let's do this quickly. Maybe we can just use the chat box lah. Okay, we can just use the chat box over here. Yeah. Can you just give one example of natural language text that maybe you think you have come across, that you think there's a problem to solve lah? Yeah. Or you find it like very difficult to read this piece of text. Can I have a better way of processing it or dealing with it? Yeah, we can just use the chat box for this activity. You can just type at the chat box. Okay, so I give you 1 minute lah to think about. Okay, if you want to work on the projects, okay, let's say if you want to work on the projects related to natural language text, yeah, what kind of text do you want to like try out? Yeah, you can type here. Maybe for your maybe some of you would like to try out text analysis projects. Yeah, for the end at the end of this training. Yeah, so you can share example of the natural language text that you like to work on. Just type at the chat box. Okay. Okay, anyone? Yeah, let me read the first one. Long remark test in report system. Okay. So Muna, can you explain a little, maybe, yeah, just enlighten us a little bit about, yeah, what kind of remark text is that? Yeah.
Company will have a reporting system to key in for a request, and then there will be part where you need to explain what is the request. So maybe we need to extract from that.
Oh, okay. So in your company, you really need to extract or go read the
Not really.
report.
I just want to know how lah.
Oh, okay. All right, all right. Okay. So, okay, Afiq, you got another one. Equipment data from data sheet. Okay. So about the equipment data, is it like rich in textual form, or is it like just a very fixed equipment names or features, Because sometimes some data can be very, how to say, some textual data can be very simple, yeah, which is, for example, the name of the product, okay, the name of the product, yeah, maybe let me see, the name, the codes, yeah, which can be processed, which doesn't really need textual processing, lah, yeah. But sometimes if you if like for example if there's a supplier name, okay, yeah, I remember one case, just one column from a company just dealing with the supplier name. So although there are a few suppliers, number of suppliers the company is dealing with, but the thing is when they write the supplier name, there are so many different way of writing, yeah. So that one, I think we need a certain a special type of processing, like maybe not the large text, but to deal with the words only, yeah, the phrases, yeah. That one is also very very interesting project, yeah. Okay. So you got close notes, Mastura, you got close notes from ticket resolutions, yeah, that's one common one. Employee feedback on engagement survey, yep. Yeah, I think in company, like normally you will have conduct the employee feedback, right, from time to time. So I think apart from sometimes we use rating, and then I think the better way is like to let them type something. Yeah, I think similarly also like every course, right, at the end, for example, this course as well, at the end of this course, you will need to write a feedback. Okay, you will need to write a feedback. So once I collected your feedback, I can actually perform text analytics on your feedback. Okay. So the description, yeah, okay, for Afiq, okay, you mean that some of the data, right? it has descriptions. Okay, usually candidate resume text details. That is a very interesting domain as well, because when candidates submit resume, it comes with a really very different format, and also how they describe. Yeah, okay, even the names, the qualifications, bachelor of something from which university, there is it is very challenging. Yeah. Usually, are you dealing with candidates' resume in your company, or this is just one idea? All right. Okay, we got previously we got one projects, yeah, one undergrad projects, like working on candidate resume for a company, yeah, in Penang. So we even have the challenge to look at the our sekolah menengah, yeah, sekolah menengah alone, it has so many different format. Yeah, some people give the abbreviated format, some spell in full. There's a lot variety lah, okay, variety on the even secondary school, even name of university in Malaysia only. Yeah, if you like, yeah, probably you can type for example, okay, if you want to type, maybe you can share your the place where you graduate. Yeah, there are so many different ways of even expressing like USM. Some even translated to English format. Yeah, some add there are some resume that add extra words. So all this like is a challenge when we try to detect the university alone. Yeah, and then we need to perform like checking regular expressions, matching. Yeah, we are going to look at regular expression today as well. Yeah, and then how to normalize it. How do we detect all USM on different form, and then standardize it to one format? Okay, yeah, similar. I think you got like the other university as well. Yeah, not only USM. There are so many different variants. Yeah. Okay, so like Muna has shared with us some variants. SMK, sometimes with dot, sometimes full capital. Yeah, sometimes mix. That one, like, wow, is a real challenge just dealing with SMK. Yeah. Okay. Okay, so let's continue. Okay. Yeah. So when we deal with text, right, there are formal and informal. Which one do you think is more challenging? Formal versus informal text. Which which one is which type of text is more challenging? Yeah. Okay. Any reason why? Yeah. Yeah, I think many has commented. Okay, informal. You got the slang text, correct? Also, slang text means when you type the text, you tend to follow your slang. Okay, and then different dialects. Yeah, dialects, because apart from language, right, we also talk in dialects. Yeah, and dialects from different parts of the countries, they have, and when you spell the words also, we follow the a certain dialects. Yeah, so that could be. So when we start to use this kind of vocabulary, or you start to use short forms in social media, that will actually that is how to say, we are actually introducing like the new vocabulary, which does not which is not found in the standard vocabulary source lah. Okay, because we know, if we want to look at the standard vocabulary, right, we look up dictionary. Okay, so the dictionary will give us like, okay, these are the proper words. These are the proper words, the word variants. Yeah, you look up the Kamus Day one. Okay, those will give us the correct words. Okay. But then as now, you know, nowadays social media, there are um so many new words. Okay. Yeah, new urban words. Yeah. By the way, Yusri has shared with one short phrase. But I don't know what is it. Yeah. Can you translate? Yeah. What does it mean? I know soba is a Japanese word. Okay. But I don't think Yusri on mic, please. Yeah. Yusri, can you pronounce and then share the translation with us? Or just translate for us? Yeah, explain, please. Yeah. We have no idea what it is. Okay. So when you deal with this informal, okay, yeah, when you deal with informal text, actually we have to use a different technique. Okay. When a text data is expressed in a formal way, so assuming you are writing a book, you have to really follow the correct sentence structure. Okay, when you write your, write your school report, write your thesis, you need to really use a proper sentence. Okay, yeah. And when you have formal way of writing, we can actually use a certain techniques like of natural language processing. Okay, they are sentence parser. We can pass this sentence. We can detect with a parser that is available in the market. Let's say for English, okay, we can actually detect maybe the structure of the sentence better. Okay, which part is let's say is the subject, which part is the predicate, which part is the maybe the noun, which one is the adjective. We can actually get that in a more accurate manner. Okay, if there is a parser for it. Okay, so the parser or the toolkit of NLP depends on the type of language. Okay, if it's a language with good resources or established one like English, what else? I think maybe English, Malay, we don't have a very, I think, very good parser yet. Yeah, that's why still research is needed for Malay language. I think English, maybe Mandarin, Arabic, they have some tools. Maybe Spanish, those are more established language. Yeah. So for low resource languages, we still need to build those analysis tools. Okay. So that's one thing. Okay. What about informal one? Yeah, as you all share, like these new words, bang, saba, bang, something like that. Okay. So all these new words will appear in different contexts, different domain. Okay. So how are we going to process it? Yeah, if we don't have the NLP, the tools for it, so we still can go for the machine learning method, or deep learning method, where we need to collect a good amount of training data, and then we train our own model based on all these new words. Yeah. So if for example, if the words appear maybe in a positive context, then it will be actually trained as positive words. Yeah, it will be trained as part of the words in the positive context. Yeah. So this is how we can still use the machine learning approach to catch all these words. Okay. Um, Then I think the more later technology is to again collect this amount of word and you build your own um, um, this interpretations model. That means you can build your own word embedding models. Like if you if there's a new word like this one, the B-E-Y, is it B-Y? Yeah, I don't know how to pronounce it. Yeah, so the if that word also always appear with other words surrounding it, then the model can capture, okay, where this word occurs. Yeah, so it will just capture this the words together with the neighboring words. That neighboring words will actually act as something like semantics interpretations the definitions okay, with the so every words, how we are going to learn its meaning is looking at where it appears, okay, where it appears. Yeah, of course that doesn't directly interpret you, like for example this one is it bay interpreted as abang. We don't have the direct translations, but that kind of model able to capture where the word is being used. Yeah, that's another way of learning the meaning of a word. Okay, especially all these like the new words and where it is being used. You can also take a look at different domain. Yeah, because you can find the text in different places like marketplace, tourism, writings, movie. Mm, yeah, if you go and read the movie review, it's very different from the review about products like Shopee. Yeah, movie review. Has anybody read a movie review before? Yeah. Have you read a movie review from IMDb? It's very long and sometimes it has a spoiler. Rotten Tomatoes, yeah. Yeah, and then sometimes they include the synopsis as well, and they talk about the whole movie. It's like they summarize the whole movie for you. Yeah, so the way when, for example, even like when review appear in different domain, the challenge of processing it is different. Yeah. So when we want to actually, for those researchers when they want to design the solutions for a particular text, right? They actually need to dive down into the context. Okay, yeah. So let's say movie review, normally it has this structure, then we have to actually really look at the how to what is actually what can we get from the movie review. Yeah. Okay, so there are many domains. Okay. So let me walk you through the text analytics landscape. Okay, and what we can do at each of the layer of this landscape. Okay, we go to the base one first, which is number one over here. Okay, yeah. So we are going to assume that we are dealing with English language, okay, English language. But the techniques that we are going to look at later, you can try to apply on Malay text as well. Yeah, because we are not going to use the natural language toolkits. We will be using English stop words, but I can teach you how to build a Malay stop words later. But you can, yeah, it's possible to apply on Malay language. Okay, so at the surface level, okay, what do we mean by understanding text at the surface level? Okay. So if you look at text, to machine the text is actually a long string, okay? So if you have one paragraph, that long string will, you have characters lah, A, B, C, D, and then space, you have 1, 2, 3. So you will actually, that is actually a long string, starting from beginning till the end with punctuation, white space in between. And how to understand the basic level, how to understand this text is we can at least try to split the text properly. Okay, you can split the long string into words. Okay, so what does it mean by words? Because when you want to ask the machine to split the long string, we need to define what we want as the output, right? Yeah. So let's say, okay, the output, maybe at the surface level, we want to get the words, all the words used in the text. So one way to get the word is to split it by white space. Okay, whenever you detect a white space, we can actually cut that part of the strings and store it as a one word. Okay, yeah. So from that kind of process, we are actually collecting a number of words. Okay, yeah. So that process itself is called the tokenization process. How we get the tokens from the text. Okay, but if you use different package, we know that let's say in R or in Python, there are different text processing packages. Different packages will give you a slightly different output of the tokens. Yeah. So whenever we apply a tokenization functions on text, we have to actually analyze a little bit. Yeah, you can use some sample, probably use one example and see what is the output. Okay, so we must actually understand really what kind of output we are going to get, okay, from that uh, tokenization process. Okay. So let's say once you get the token, so we know we got words. So the basic thing is we can actually look at the words, okay, look at the words. But there are some treatment that we can actually apply at these words. Okay. Because yeah, one of the issue that we mentioned just now, what if the same words is presented in different way by different people? Okay, yeah, let's say if USM is spelled differently in that text, so what can we do? Okay, yeah, so one of the one way to help us to process the text at the surface level is you can actually try to standardize, okay, standardize the variants. Okay. Then there are also some methods like you can actually uh, combine the maybe plural and singular as one word. Okay, if you have plural, if you have singular, are they the same, or you want to merge them as one? Yeah. So these are the process that we can actually apply at the surface level. Okay. Yeah, I think basically we have normalizations or even some cleaning lah. Yeah, because once you tokenize, you may find that some of the text actually maybe it's a not text. Maybe there are sometimes like there are things that you need to clean first. Yeah, so that can be happening at the surface level. Okay, we don't go to the meaning yet. We're just trying to look at the words. So at the second level, the meaning of the text, yeah, that will be actually it's a level deeper. Let's say when you have words, okay, you tokenize it and then you got some of the words. Okay, maybe I write some, maybe this one might broken. Okay, might broken is you got two words lah. Okay, yeah. So you want to understand the at first. Let's say you that sentence only got two words. So you got, let's say you got punctuations. So the tokenization process will actually give you the let's say we ignore the punctuation. It give you two words, might and broken. Okay. You can keep might as it is, or you can standardize it, because like might maybe can be is it microphone? Okay, yeah, you can standardize it. Okay, if you don't standardize it, we are going to keep it as this raw form lah. Okay, this raw format, yeah, the original form lah. So you got two words, might and broken. So if you want to, let's say, okay, we deal with this form. A simple way to understand a little bit more about the word is we can actually look at what is the word class. Okay, what is might? Okay, so word class is actually the, you know, the, if you still remember the part of speech, a might is a, okay, let's say it's a noun. Okay, yeah, kata nama, this one. Broken is, what is broken? The might broken. Yeah, can someone guess? The mic is spoiled already, it's broken. What kind of what kind of word class is this? Is it kata kerja or kata adjective? Mic broken. Okay. So let me find one more example from out there. Kata sifat. Okay, so let's take this one is adjective. Right. Okay. Maybe we take a look at one more, the longer one. The what? The career service is very slow. Okay, yeah. So you can get, like, let's say if you have sentences, then we will get words like this lah. Okay, yeah. So at the meaning level, what we can do is we can try to understand maybe the basic one is the word class. Okay, is the word class. So what part of speech is this word, and what part of speech is the other words? Okay, and when you know the part of speech of the words, okay, so what can we get from it? I mean, how can we use the part of speech? So let's say if you know that a particular word is a noun, okay, let's say this word is a noun. Okay, maybe this one is a noun, this one is a noun. Okay, you could also get this one is a noun phrase here. Yeah. So if you know that a particular word or phrase is a noun, then one of the advantage is we know that this is probably the main key. This could be a keywords, okay, or this could be the target of the talk. Okay, so let's say in review, normally noun is probably is the target of the about the products or about the features that people are actually praising or complaining. Okay, yeah. So it depends on the domain of your text. So that is one thing. So if you look at adjective, so like let's say you got slow, broken. So adjective will actually link to the what? Sentiment, right? Yeah. So there are certain adjective words that falls into the group of the negative sentiments. There are also the certain words that is positive, okay, showing positive vibes. Yeah. So this is where we can actually use these hints to understand that okay, then this word could be actually expressing sentiment, okay? Because we know that sentiment normally comes with the express using adjective words, okay? Yeah. So that is one simple way lah, okay, to help us to understand the a little bit more about the text. Okay, so at the third level, let's say you already have some words, you know what class is it. How can we perform text mining? How can we mine some information from the content? Okay, so this comes the some probably you can use some let's say statistical methods, countings, you know, to get the information. So one simple way is, let's say we can perform simple counting. You can count how many words has been used, okay? Yeah. Let's say if people talk about slow, okay, how many people actually talk about slow in this review? Okay, how many talk about fast or so forth? So you can perform simple counting to look at the, let's say, maybe the adjective class. Okay, what are the adjective words being used? Which one is mentioned more often? Okay, compared to another. Okay, so that is at the word level. There are also another method called, okay, let's say n-gram. Okay, yeah, we will go through this as well. So n-gram is also a way, okay, one way to discover the to mine some important contents from the text. Okay, so how it works is n-gram will actually look at try to capture the word sequence. Okay, for example, two word sequence or three word sequence, or fourth, or so forth lah. Okay, yeah, you can have three, or so this is 2, 3, or you can have 4, and so forth. Okay, the interesting part about n-gram is, because the first thing is we do not know how the sentence is formed by the reviewer, right? Yeah, because the reviewer can write about anything. They can form sentences. For example, they can just now I think use reshared like might broken. Yeah, some people shared might is broken, then some say might already broken, or there are many ways lah, or that the sentence can appear. And also there can be a lot of probably new complaints lah, okay, new complaints that coming in, new phrases being used. So we don't know what's going to appear. Actually, we don't know what to expect. So n-gram will allow us to discover the popular word sequence used by the people. Okay, yeah. So at the end, n-gram is still going to, it is still a rank lah. We are going to rank the just like counting. Normally after you count, we will rank it. Yeah, it's still a rank of words, but the thing that makes it different from a simple word counting is now you actually can discover the popular phrases used by people. Okay, yeah. So you can actually capture the phrases used by people, and we tend to discover what people trying to talk that sometimes we don't expect. Yeah, they will comment on this. So this is the place where we can do the discovery. Okay, so you can discover what people say lah using n-gram. Okay. At single word level, we still can discover, but it will be a bit short lah. Yeah, sometimes we will miss the context. Okay. Yeah. Moving to number 4. Okay, how can we model text contents to obtain knowledge. Okay. So this is the part where we bring in the, let's say, the AI components. So let's say if you have, yeah, here we are going to talk about model. Let's say you got mic broken, and then, okay, mic is very clear, okay, yeah. Oh, the mic, the speaker clear, the mic is okay. Okay lah, just for example lah. So the one way is to trying to build a model to learn whether a certain command is positive or negative. Okay, yeah. So this is negative, this is positive, let's say. Okay, so you can use method like maybe supervise method. Okay, supervised ML. This one we will look at it next week. Okay, yeah, a supervised one you will need to get ready some label training data. Yeah, I think this one you also have gone through in your machine learning module or deep learning module. Yeah, so you need to prepare the label data. Okay, but over for this module it will be text data. Yeah, so you will need to prepare the data and train a model. Okay, train a model. So you can have a number of this one, maybe let's say 100 here, 100 here, small size lah. Okay, 100 each, balanced data. Then we build the model. Okay, we build the model. So once you get the model, okay, you can use this model to perform predictions. So if you have a new text, okay, yeah, if you have a new review, you can use this model and ask the model, okay, now you predict for me whether this review talk about positive or negative. Okay, yeah. So this is how we trying to get the a model to suggest some outcome for us lah. Yeah. So this is the number 4. So this is briefly what we are going to go through in this for this module. Yeah, we will be emphasizing on okay, 1, 3, and here lah 4. Okay. So perhaps we take a 15 minutes break, and then I'm going to just walk you through some example of the techniques. Yeah. Then before we proceed to the hands-on, okay? So we take a 15 minutes break. Then we continue to look at some example of the techniques. So you can refresh a little bit. Then we, yeah, continue. Right, okay, so see you, okay, now it is 10:50, right? See you 11, what's that? 11:05. Okay, 11:05 we continue. Okay, see you in a short while. Okay. Okay, so let's continue. Right. Okay, so I'm going to walk you through a few techniques that we will be looking at, okay, during the hands-on later. Okay, so okay, let's take a look at the first one. So the first technique that we will be actually using is the called the regular expression technique. So what is the, okay, how can we use the regular expressions in text lah, okay, in general. Okay, so I think in normally when we want to start processing the text, okay, we need to do some cleaning. Okay, we need to do some cleaning. Okay. So this sample is a tweet. Okay, it's a tweet. So I think for tweets itself, it should be quite it has a format of a tweet. But if you are actually looking at other type of textual data, maybe for example from the some reports or some logs generated by the certain processes in your company, you will tend to see some parts which are noise that you will need to actually do some cleaning. Okay, so one way of using regular expression is you can use you can write a patterns of regular expressions to do the cleaning of the text. Okay, so how can we do the cleaning is like you can detect the patterns and then replace it by a blank. Okay, yeah, that is to remove a certain part of the text. Okay, and okay, another way is also we can use the regex to do the locate. Okay, yeah, so if you know what you want to find in a text, we can actually directly use regular expressions patterns to look up the particular words. Okay, yeah, so that is when you know what to find. Okay, when we don't know what to find, then we have to use the other method. When we know what we want, for example, if the text in the large piece of text, we know we want to locate all the company names, and then you already have the list of company name, let's say like Google, Yahoo, Amazon, and so forth. If you have that list and then you want to find out which tweets actually uh, contains Google in it, so we can actually use these patterns to help us to locate where actually Google's appear, in which of the records it appear. Okay, yeah, that is for the locate. Okay. Then if locate, then substitute or to change the words. Um, that one is for normally is for normalizations or standardizations or to remove the noise. Okay, yeah. If we have like let's say if you know like there are certain errors normally committed by people when they are writing maybe university names. So in the first level of text processing is like you can write expressions to do those replacement. Okay, so this is a rule-based method lah. Yeah, you need to actually write a series of rules to perform some standardizations and to do the cleaning. Okay, so this is how we can use the regex. Okay. Okay. So second steps, like after you have cleaned the noise, we can use a series of standard text preprocessing steps to further clean the text. Okay, yeah. So for example, there are steps like to remove numbers. You can remove punctuations. If there are extra spaces, we can remove it to make the text looks better. Yeah. Okay. So at these steps, we can actually what we want to do is actually to make the text ready, okay, for the counting part later. Okay, yeah, for the text mining later. Yeah, because if like if you know that you don't want numbers, okay, yeah, then at this level you can remove the numbers. Yeah. But at the end, I think if what are the steps to apply is like it depends on what you need lah. Yeah, yeah. So we have to actually design accordingly. If we need the numbers, then we don't remove it. So it depends on what we want to achieve at the end. So there are always the text text mining packages, they will have this a series of pre-processing steps that we can actually use. Yeah, so we will try this as well. Okay. Then yeah, followed by standardizations. Yeah. So if you have removed all the words that you don't want, then the next another crucial step will be standardizations. Yeah. This part we will actually handle the for example, okay, word variants, okay, different way of writings, okay. But the handling of word variants, for example, like this, we will again use some rule base, yeah. So that will actually, it has overlappings with the regular expression part just now. There are certain rules that we need to actually write and do the replacements for standardizations. Okay. Case folding is to deal with the use of capitalized uh, alphabets. So if there's a, some of the word, if it begin as the first word of the sentence, so we will have a capitalized alphabet, right? So in that situations, the case folding will actually standardize it so that we get the same set of words. But okay, in general, if you perform case folding to all the words, then some of the names will also become lowercase. Okay, yeah. So all the after case folding, all the uppercase will be changed to lowercase. So let's say coincidentally, if a person names is a noun or it means something else, then we will actually lose the name lah as a name lah. Yeah, yeah. So there's other method lah to detect names and for example like special names of like this. That one there's a package that you can use. It's called the name entity recognitions. Yeah, but just for your knowledge, we won't cover in this module. So there's just a package that you can also explore. It will help you to detect like person, organizations, maybe numbers and so forth. Okay, or dates. Yeah, I think this is the common one. Currency. So that one you can use NER package to pick out like specific names, persons, organizations from the text. Okay. There's another method for standardizations is called lemmatizations or stemming. Okay. So lemmatizations or stemming, it will help us to handle the word variance resulted from the linguistics variance form. For example, like if you have like cat and cats, okay, yeah, right. Then you have wrote, written, writings, and so forth. Yeah, this is the linguistics methods that help us to standardize this to a base form. So the base form is cat, the base form is right. Okay, yeah. These two has the same goal, but they are using different way of doing things. So we will look at the example in a short while. What is the difference between lemmatization and stemming? So after that, there's one more step that we will also try, which is the stop words removal. Okay. So given the text, like after pre-processing, and then after you remove the punctuations, numbers, you have standardized, and then like you have changed all to lowercase. we have actually reduced them to the root word, there are still some words that you may want to remove. Okay, so this is the part where we try to retain the text that we want to analyze. Okay, yeah. So stop words can come in by the removing the stop words lah. Okay. So basically, okay, here the stop words means that these are the words that appear very often in the text, and it has no significant use to in the interpretations of the information. Okay, so example of stop words will be maybe you know, like the let's say maybe he, she, yeah, so forth. Yeah. So there is a stop word list that has been prepared lah. For example, like in the package that we are going to use, there's a English stop word list that has been built. Okay, that we can apply straight away. If we want to build our stop word list, it's also possible. Okay, yeah. So we'll talk about how to build the stop word list as well. Okay, yeah. So that you can build your own stop word list and apply it. So this is one thing. So after you remove the stop word, normally we will see that the raw text from after these few steps, it will become more compact lah. Okay, you have much lesser words, and these leftover words will be the one that we are going to analyze. Okay. Of course, at this stage, there are other process that you can perform also to improve the quality of the text that we want to analyze. Yeah, because we know that this will be the input for the subsequent module. Okay, so we at each of the stage lah, I will say at each of the stage is very critical lah for us to process it well, so that the end result will be the one which is meaningful one. Okay, yeah. So there are certain like let's say domain specific handling that you need to apply, then we have to do it as well. We have to, for example, like this is probably the social media domain or social media tags lah. Yeah, where you have to perform some standardizations. Okay, language as well. So if there is a mix of language used in the text, so how can we handle it? Yeah. So if someone use like more than one languages in the text, yeah, would you want to like translate it to the same language, or just retain it, yeah, in this original form? So these are actually the decision that we need to make at every steps of the text processing. So about the discovery, yeah, we will have a single word, and then there will be, so this is about the n-gram method. Okay, so n-gram, I think commonly we go for bigram and trigram. Okay, yeah. If you want to go for, because n-gram stands, comes n-gram, right? This n, it can be any numbers. Yeah. But if you are generating the higher level of n-gram, let's say quadrigram as and the longer one, you will tend to get a lot of terms here. Let's say this one we treat it as one term. This one we treat it as another terms. You will tend to get the terms which is very rare because we know that as the sequence grow longer, it will become rarer for you to have the people talk about the same sequence. Yeah, so you will end up with many n-grams that is probably appear only one time perhaps. Yeah, and your your word vectors will become very, very huge. Yeah. So there's also one issue that normally happens in the text processing or text representations field is the maybe you have heard of it. We call it the dimensions problem. Yeah, dimensions means that you are going to get a lot of words. Yeah, the dimension is so high. Yeah, so one of the tasks will be to reduce the dimension. That's why you may heard of like dimensionality reduction. It's one of the area also in research. Yeah, we want to reduce the dimension of the words. Okay. Yeah, so n will be the number in one terms. Yeah, correct, Muna. Yeah, so two. Yeah, so 2n means two word lah in a sequence. So let me show you a few concepts. Okay, so I will point out the critical one. Okay, so as we talk about words, right? Yeah, so it's important to, as the first step, I think, error like to detect the word in the sentence. But what we are going to use is the tokenizer, okay? We are not going to build the splitter ourselves. We will be using the tokenizer, but later we also need to inspect the output of the words. If you parse a sentence, or if you tokenize a sentence, what is the words that you are going to get? Okay. And when you want to define the words that you want to keep at the end, let's say if you want to, like later we'll be seeing this, okay? So there will be for example, a word vectors like this. Okay, so this will be you will have a word list here. Okay, these are the words that you will be analyzing. Okay. So if you want to determine, okay, we have to actually determine what we want at the end, okay, here, because this will be the one that will go into the next steps, okay? Maybe for, let's say, mining, for classification, that will be next week. Yeah, so the words here is very crucial. If we say that I want both cat and cats to appear in my word vector, okay, then I will not perform maybe the lemmatization because I want to differentiate between cat and cats. Okay, yeah. But if I want to combine them, if I want to treat them as one word, okay, so let's say maybe rabbit. Okay, I only want to keep rabbit. I don't want to know how many rabbits. Like if you have plural rabbits, they are still rabbit concept. So I'm going to reduce them to the same word. Yeah. So that is where you have to perform the lemmatization. So the idea here is the definition of word is like you have to decide lah. You have to decide, okay? Yeah, because that will actually the pre-processing steps that you are taking is actually going to affect what we are going to get in this list. Yeah. So there's a just for you to take note lah, the difference between word tags and tokens. Okay, so tokens are because when you look at the text, if you run the total word count, that will be the tokens. Okay, what are the total number of running words in the text? Okay. And the other concept here is the word type. Word types is the distinct words. Okay, distinct words. Okay. It's interesting to know how many tokens and how many word types in the text as a data scientist. Yeah. Okay. Actually, in one of the text, the text exploration steps, the one one of the important part is like to find out, okay, how many tokens, okay, although it's very simple, how many tokens is your data set, because this will actually explains, like it will show how big is your data, right? Yeah, if you tell people like, okay, I'm working on this review data, okay, then but what is the size? Okay, yeah, what is the size? Is it like 100 words, 100 tokens, or is it like 1,000 or 1 million tokens? So that gives an idea on the size of the data that you are working working on. So, and then the other one is the types. Okay, how many distinct words are there in the data set? Okay, if you look at one data set, for example, okay, let's say maybe the review data set. It could have like 1 million tokens, okay, and maybe let's say 1,000 word types, okay, yeah. So this is your N, this is your V, okay. And if you compare to maybe just now the remarks, okay, the software remarks, remark notes, okay, it could also have 1 million tokens after you collect from one time to another, you know, from time to time. But it may have only let's say 100, okay, 100 words. Yeah, just to compare between these two. Let's say maybe this one 10,000. This one, sorry, 1K. Okay, yeah. So what I'm trying to show here is it depends on the domain. Okay, it depends on the domain. In a freely expressible domain like review, you tend to get more unique word types. Okay, yeah, you tend to get more unique words because people tend to introduce new vocabulary. They tend to use new words, right? Yeah, so you can get more word type. But in a control domain, just now I think one of the participants here mentioned about the remark notes. Yeah, that because the remark notes is limited to maybe the feedback towards your you know the context of the machine that you're dealing with, the output that you're dealing with. The way of writing the remarks could be a varies, but the words that you use could be that few different words only. It won't go beyond that scope lah. Yeah. So if you compare these two, you may get a relatively smaller number of word types. Okay. Yeah. So for Afik, the tokens are the words that we are looking for. Yeah. So basically, I think the first step will be the tokenizations. After tokenizations, you will get the tokens. And then what kind of tokens to keep? That is also, if you tokenize raw data, you will get the full raw data tokens. But if you perform tokenizations after you do the stop word removal and and other steps, so basically the token will be I think will be the clean one lah. Yeah, it will be the clean one. But then after that also there will be a distinct words lah. Yeah, from the tokens. Yeah. If you want to do counting, then that will be the word types. Yeah, the word types from the tokens. So the domain actually will affect the approach that you are going to use. If let's say we are only dealing with very small set of vocabulary, okay? If you are dealing with like small set of vocabulary, you may need a simpler approach to solve your problem. maybe there's a dictionary that you can prepare, okay? Yeah, to detect a certain word being used, you can implement some rules to perform standardizations on the words. Yeah. So the solution actually depends lah, I think on the domain. Yeah. But if you are dealing with like reviews, right, I think we still have to we really cannot catch all the different word types. Yeah, so we have to still go for machine learning techniques. Okay. Okay, another activity. Okay, can you let me see. Can you highlight the sequence of words which is useful? You can maybe type in the chat box. Yeah, you can just write down from this passage. Okay, what 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 is the sequence of words? You can treat this as n-gram, 2 gram, 3 grams. So what is the sequence of words which you think is useful for text analysis? Yeah, you can type at the chat box. Okay, so Anisa, wait, let me see. Let's say if I'm processing Teams recorded transcript, the clean version is after removing the field pauses. Okay, so if you processing the recorded transcript, that will be, yeah, you will get a lot of these pauses, right? Removing field pauses. Yeah, I think you can remove the pause first, yeah. Then actually the number of total tokens it is flexible lah. It's just a way of counting. Okay, you can also, if needed lah, you can also report before and after clean. The original transcript, you may try to tokenize also. Yeah. So the original transcript, maybe you have like 1 million. After you remove the field pauses, then maybe you have like how many thousand? You have a slightly less lah. Yeah, tokens. So it's just a way of showing what is the size of the data. Yeah. Okay, Zaino, okay, got her name here. Economic activities slow down. Okay, so I got one example. So Hanin, you have suggested the sequence of words without two lah. That means you have, I assume here you have, if you really want to catch that words, right, that sequence, we have to perform maybe a stop word removal. It depends on the stop words. If it doesn't include the conjunctions, then you have to maybe, yeah, include some of the conjunctions. So COVID-19 pandemic, so Malaysia's economic activities, yeah. So you see, when you select the sequence, there's a tendency for us to select something that has a noun, or it has a noun as a noun followed by other words, yeah, or probably a noun phrase. Yeah. So this is the actually one way of helping us to identify what we want, because if you have a piece of text, right, if we just process the text without any goal, then in the end we are also not sure whether the processing step actually is needed or not. But if you have a goal like this, okay, you know there's a certain sequence of word that I am targeting. You know, like okay, I'm going to, at the end of the day, I want COVID-19 pandemic. So the pipeline that you design later, you can orientate towards that goal. Okay. If you, okay, in this, like for example, okay, let me see. If you want to catch this word using n-gram, then we will need a very large number of data set. So if I believe, for example, COVID-19 pandemic, this can be this can be actually mined. Yeah, you should be able to get it if you have a large data set. So the rest, you should be able to find this sequence from the outcome of the n-gram. Yeah, but then if you get the n-gram outcome, there will be many. So filtering can be done. Yeah, you can apply like another step to filter which n-gram you want to discard, which one you want to keep. Okay, yeah, so this is actually a step by step. Yeah, we need to keep on improvising the process. Okay. So regular expression, just now we talked about it, is a patterns. Okay. So if you know what you want, like let's say if you want to detect the keyword COVID -19, so you can actually put that pattern in and to detect which of the text actually has that pattern. Okay, that is when we know what we want. Okay, so we can use it to do replacement, to do detections. Yeah, we will have one hands-on of regular expressions to do the cleaning. So, okay, this one I think we can skip because, yeah, just patterns to locate the word. Okay. So for normalizations, okay, the normalizations will be applied on your text tokens. Okay, yeah. So before you can normalize, we cannot normalize the long strings basically. There should be a process that it already detect the tokens in the text. Yeah. So, but don't worry the tokenizations part will actually you can use tokenizer to tokenize, or it will be actually it's embedded in the lemmatization or stemming functions. Okay. Yeah, you will see that but particular words will be detected. So we don't have to like tokenize first. Yeah. So in general, the output of the tokenizations you can use as it is. Okay, so you just use the token straight. But in case there are certain variants like what we talk about that you want to standardize, in that case you have to either write regular expressions to do the replacement. Okay. So let's say if you want to convert all the USA to US, okay, so you have to we have to write the regular expressions patterns to perform substitutions. Okay, to substitute this pattern with another patterns. So there are other standardizations like okay, case folding. Okay, case folding reduced to the lower case. Okay, yeah, this one I want to touch a little bit more about the reducing the words to the same root form. Okay, yeah. Just now we talk about like there are two methods, lemmatizations or stemming. Okay, yeah. So now we want to look at the difference between these two methods. Okay. Both have the same goal. They are going to reduce the words into the root form. Okay. For lemmatization, the idea behind is it's based on the linguistic rules. Okay, so this is the input, for example, this will be the output. Okay, this is the input, this will be the output. Okay, so what's happening at the back end is a lemmatizer, it's going to take the words. Okay, so it will take a word, for example, like cats. Okay, cat is a word, and then it's going to detect the morphological it's going to detect the morphological structure of the words. Okay, so let's say cats, according to the morphological study, this particular word, it actually made up of a smaller unit called the morphemes. Okay, so this word actually it has two parts. One part they call it central morpheme. This is the central, the one that supply the main meaning. Okay, so this is your cat lah. Okay, the kucing. And there's also another part, the affixes to the stem. This one will add additional meaning. For example, this means plural. Okay, yeah. So lemmatizations, if you call the lemmatization functions, the process that it's going to take is it's going to analyze the words, okay, and then breaks it, and it will return you the root, which is this one. Okay, so this is what's happening at the back end. And okay, the other the other one is stemming. If you use a stemmer, stemming functions, it will also reduce to the root form, but the stemming is based on a series of also a rules of reducing the okay, for example, the words. Okay, how it reduces, it's going to have some rules. Okay, maybe I'll show you the rules first. Yeah, so these are some stemming rules. Okay. For example, the rules say that whenever you detect SSES at the end of the strings, it's going to replace with SS. So when it detects like this word, it will change to this. Okay, so if you have like glasses, okay, we attend glasses, so it will SSES, it will keep this, so become glass. Okay, so this is how the stammer works. Okay, it has a set of rules. But then, if you look at some of the rules, okay, here at this end, yeah, some rules like this one, it will change the meaning of the words. Okay, yeah, for example, like this one. If you see like these rules from like activate, okay, activate, you will become active. Suppose if you use lemmatizer, you will get active, right? This one, but a stammer will give you this output based on the rules. Okay. So what is the pro and cons of these two? Okay, lemmatizer, because it's built using linguistic rules, in some languages, you may not have a lemmatizer. Okay, yeah, because you will need the linguistic approach to parse the words. Okay, some language may not have. And okay, if you compare to the stemming process, the processing time is longer. Okay, processing time is longer. Okay, but for stammer, we know the limitations. It will cut off the end of the words. Why this happened is because when the rules was learned, it's based on a set of data set. Okay, how stammer got these rules is you will need to supply it with a set of a large data set. From the large data set, let's say, let me go back to this. Yeah, the large data set will have many words. Okay, so the stemming algorithms, it's going to detect the words and the overlapping substrings of these words. Okay, so there are certain way for how the stammer will work. So for example, here it probably detects this one. There are 3 words here, right? So the overlapping part is up to the T, right? Yeah. So there's a rule saying that if you see this, it will actually reduce to this format. Okay, so the stemming rules is actually learned from the data set. Okay, yeah. So the good thing about stemming is if for a new language or for a low resource language, let's say for Malay, if you don't have a Malay language, if you don't have a lemmatizer, we can quickly build a a stammer, okay, by supplying this by learning the rules from a large number of Malay words. Okay, so there are pros and cons lah. Which one to use? It depends on the outcome lah. I think if the words that you how to say, you normalize if you want to normalize this paragraph, if that output, let's say if this output, if you want to use it directly to extract some keywords and to present to the end user, then it's better not to use the stemming, okay, because you will end up with all these words, yeah, like this one, yeah, you will be presenting all these words to the end user. But in case you are using this as the middle, the intermediate steps, after you stem this one, I'm going to actually, this is just a word vector for me to train my classifier. Yeah, in that case, you still can use a stemming output. I will also show you the next week how stem output is used in retrieval, information retrieval. Yeah, the text search part. So this is the difference between stemming and these lemmatizations. Okay. So this is the final one, stop words. Yeah. So example stop list. Okay. Yeah. So we can use the list that is already available. I think if you Google, you can easily find different stop lists that has been built and shared. Okay. Yeah. So what is the strategy to build your own stop list? So you can actually build your own stop list by preparing a good number of data sets, okay, a large number of data, and just tokenize and sort the terms by the frequency in the collections. Okay, yeah. So that once you sort the terms, you will tend to find that the one that appear at the top of the list will be this kind of words. Okay, you will tend to find these words appearing in the top of the list. So this is where you can actually pick a cutoff point. Yeah, because the words is everything. The list is, you will get a rank list. You can pick a cutoff point, and of course you can also review the word list, and then you can take that as your stop words. So yeah, this is one strategy to build your stop words. You may try it for other languages or for the dialects kind of text. So stop words can be applied in different situations. Yeah, because, for example, in a supervised machine learning, yeah, we need to reduce the dimension of the feature space. Yeah, so we have to remove the stop word. Otherwise, there will be a lot of noise learned in the model. Okay. Similarly, for other tasks as well. Yeah, like clustering, we want to output the cluster. Okay, the clusters. Yeah. So we don't want, when you want to generate the clusters, we don't want the stop words to influence the calculations of the documents in the clusters. Yeah, once you have stop word in there, it will affect the similarity score. Okay. Yeah. So retrieval, we will look at that. How can what are the words that should be indexed? which are the words that shouldn't be indexed. Yeah. So normally we don't want stop words to be indexed. Okay. And lastly, I think for yes, summarization as well. If you want to generate a summary, okay, summarization score. One long text. If you want to, okay, this is the raw text and this is the summary. Okay, yeah. So okay, let's say after you get your summary, normally we need to measure how good is the summary. Okay, is this good enough or not? Okay. So one way of measuring is to compare this summary. This is auto lah, okay, auto generated with a summary written by a human. Okay, yeah, human. This is a gold standard. Okay, yeah. So when you measure the how good is the summary, normally we have to benchmark it against a gold standard. Okay. So when we do the benchmarking process, right, we do the matching, the measurement, we normally need to match how similar is this summary to the one generated by human. So one way is to measure the overlapping words. Yeah, whether, okay, this and this, how similar they are. Okay. Yeah. So if you use stop words, because some of the stop words may have, you will appear here and some also will appear here. Yeah. So one way is to exclude the stop words. Okay. In the summarizations, similarity score matching. Yeah. So you can actually remove the stop or disregard the stop words when you do the score calculations. So that is for the text summarizations. So there are, when you want to clean these stop words, there are also a certain practice. Some domain specific text, you may need a domain specific stop words. Okay, if you are dealing with like legal text or health text, medical text, there could be a certain stop words that you have never actually thought of or seen in a social media kind of articles. Yeah. So for domain specific data set, normally we also try to look at what are the stop words that we can build, and then we can how we can improve the quality lah. Yeah. So there's also another one is like for example, in sentiment analysis domain, there are certain words that if you remove it, right, then it will affect the interpretations. Yeah, if you remove like not, okay, yeah. So let's say if this thing is said is not nice, okay, yeah. If not happen to be stop words, then it will actually it will actually change the meaning lah, okay, change the meaning. So we have to be very careful. Yeah. In some domain, yeah, or in some analysis where you have to analyze the full sentence. Okay, she, okay, she is the maybe is the maybe she's the waitress. Okay, yeah, and okay, just one more sentence. Say. So if there's a case where if you need to keep this she in the analysis, then we have to we are not going to apply any stop word removal. Okay, yeah. So if like maybe okay, and works in maybe this a shop lah, huh? Okay. Maybe works in Coffee Bean lah. Okay, so she is the waitress. So there are certain analyses where you need to know that who is this she. Okay, is she, this she is actually refers to Hannah. Okay, so the in this kind of situation, normally we don't remove any stop words. Okay, so this is where you try to analyze the linking between entities across sentences or even within a sentences. Yeah. So we have to be very careful when to do the removal and when not to do the removal. So can we take a quick look at the text down here, this one? Okay. What are the words that you think can be removed? Yeah, we look at the Malay one. Yeah, the BN text down here. Can you suggest some of the words that can be removed? Stop words lah, maybe a potential stop words. Yeah, yeah, Mona, I think we straight away look at the down there one. Okay, if you want to perform like cleaning, reduce the dimension of this paragraph, reduce the token size, the unique words. What are the words that you think you can discard? Yeah. So one way of building the stop word list is also like list down manually. You can eyeball the like the text, and then okay, we try to maybe list down a few. Yeah. So of course that one you have to go through a lot of text manually. But the best way is still like we have to generate it automatically. Okay, collect a large number of text and then generate the stop words. Okay. But I think in general you are suggesting like some conjunctions kind of words. Yeah. So we got like maybe you have untuk, could be have sedang, I'm not sure, dengan, di, so forth. Yeah. Okay, so these are some examples of the potential stop word list that is actually not contributing, okay, to the we won't use it as the main keywords in text mining. Okay. So lastly about ngram, yeah, just to show you the how you can get the sequence. So the ngram sequence that we are going to look at is actually is different from the language model. Okay. The ngram language model is a probabilistic model, the basic of the LLM, the large language model, yeah, for the ChatGPT. It's also based on the sequence. Yeah. So the one that we want to mine is like 2 words in a sequence, 3 words in a sequence. It's just by capturing the sequence of words that appears in the sentence. So you can have example. This is like if you have 3 words, egg fried rice, so you can get egg fried and fried rice. Okay, so you got two bigram. Okay, 2 bigram here. So the idea of ngram is we are actually relying on the importance of word sequence, okay, in these aspects of text mining. Yeah. So how people form the sentence is very important. Okay. Yeah. Okay. So yeah. So I think that's the end of the overview. So we will end this with one activity, which is to identify keywords from review. Okay, identify keywords from review. Okay, so the task is to study the review text from this site. Let me share this. Okay, let me paste this in the chat. So you will need to go to this TripAdvisor site, okay, about this tourism spot. Okay, you can choose a different review to read lah. Okay, there are I think more than 20 of you. You can skip a few reviews and you can pick one to read and pick 3 keywords that you think is important, okay, from the text that you want the people to know. Okay, and then you share the words at this link, thementi.com. I'm going to switch to this site in a short while. Okay. So the task is to read the review, pick a few keywords, yeah, and submit it at the menti.com. Okay. So we will be building a word cloud from the keywords that you have actually identified from the review. So let me move to the Menti. Okay. Are you able to access the TripAdvisor site? This one? And also the menti.com site. Okay, let me switch to the So I give you a moment to read the review and also to submit the keywords. Got this one. So the keywords you can submit one word, 2 words in a sequence, or 3 words in a sequence. Okay, that will simulate the engram that can be catch from the review. Okay. So I'll give you 1 minute to do that. Yeah, a quick one, just a quick activity. Yeah, you can submit at the menti.com. Yeah. Okay, so all right, let me look at the words that you have shared. Okay, so what you are doing now is actually going through the review. Okay, so just assume that this process can be automated. You actually, there are some words of one word, there are some 2 words, 3 words. So the process actually need to go through tokenization to get these words that you have actually shared. You also need to tokenize and then engram perhaps to get these phrases. And also they are, okay, what else are there? Let me see. So you got like helpful stuff. Okay, you got fun. Fun is bigger. I think okay, there should be more than the count should be more than others lah. Like, and then great and funny. Okay, so you will see that many of the words are actually the descriptive one. Okay, you can see that there are adjectives being used. Amazing. Then also other than adjective, there are also like adjectival phrase. Yeah, and there are also okay, noun phrases. Okay, like Ali. Okay, Ali must be the park assistant, park ranger in the escape. Okay, so there is a mix of good and bad response over here as well. Okay, yeah, so you can see that it is a mix lah, because we only build one cloud for everything. So when we build one cloud for everything, we tend to see a mix of everything in there. What you can do is if you have a dashboard, if you want to build a dashboard, we can actually build separate clouds. One cloud for the, let's say if we have a positive cloud, and then the other cloud for negative cloud. Yeah, then you have two clouds. People want to look at positive words, then go for positive clouds. Negative words, look at negative clouds. So there can be two clouds as well. And also you can see that there are some features being brought up, like Face ID entry. Okay, yeah, this is one of the good things. I mean, it actually facilitate the entrance of to the park. Okay. This one, Sumon, is it a person? I'm not sure. This one, yeah, poor timekeeping. Yeah, so if people see this kind of word like the just now it's very frustrating. Yeah. So normally when you pick out all these keywords, and at the end of the day we want to show to the end user. So these keywords, it should be actually linked back to the original review. Yeah. So definitely if we see very frustrating, the next step would be to click on this and it brings us to the original one, so that we can actually read a bit more about this point. Okay, so this is one sample word cloud. So at the end of the day, you will be building a word cloud for the tourism spot that you have shared in the morning. Okay, do you still remember the tourism spot that you have shared in the morning? Yeah, I think some of it are very special. You may not have a review. Yeah, that one you can change to another one. So for those who have a review, you will do the collections and generate a cloud, okay, for your for the tourism spot. So let me just capture this screen. We capture this with the paste it here. Okay. So this is a take-home activity for you to think about. If you have the source, like now what you have read, and this is the outcome that we want. Okay. Yeah. By the way, what do you think about this cloud? Do you have any comments? What about what do you think about this word cloud? Is it one of okay, this normally I think one of the basic component of the things that you can put in your dashboard is the word cloud. Yeah, you can also there can also be word lists. We can also have some charts in the dashboards, but this is one of the components. Okay, yeah. So we will be developing this later as well. Okay, so think about the process. What are the steps that you can take for you to get to this club? Okay, yeah, that's a one take-home activity. Okay, I think this is the last one. Yeah. So if you notice the TripAdvisor site, right? Just now the TripAdvisor site, there's a section where there are keywords, okay, generated. Yeah. So just quickly look at these keywords. Are there any overlapping keywords or not with the one that you have extracted? Yeah, I think I noticed one already, Ali. Yeah. Although Mr. Ali and Ali, yeah, you both mentioned about Ali. Okay. So this person must be very important. So what we are trying to do here at the end of the day is we are trying to pick good keywords, okay, from the text. And then after you have discovered the good keywords, we can actually put them forward in a section like this in the website or in the dashboard. Okay. And we can, like, for example, things like this one is clickable at the TripAdvisor site. You can click and then it will bring you to the review. Okay, so people talk about like Tabi race and so forth, the camping experience. Yeah. Yeah, so this is one of the interesting output that you can actually produce from the outcome of the text mining. So this is the last, second last. Okay, this one is just acknowledgement. Yeah. Yeah. More readings, references for you to check out. Okay, so that's the part of the overview. Okay. Okay, so we are going to continue to look at the R and R Studio. Okay, R and R Studio. Okay. I will, okay, now it's 12:15. I will give you a 15 minutes short break to download the software and yeah, to do any installation if needed. Okay, yeah, just around 15 minutes you can get this ready, and also to download the data set. So this is the script. Okay, yeah, this one, second one. Okay, there's one more script that I want to share. Okay, I'll do it in a short while. Okay, and the data set here. Okay, more data set. Yeah, so you can download them first. So the software, you can just go to this site. So it's over here. Yeah, you can download it. So when you click on that site, it will bring you to this. Yeah, and our studio, this one on the right side. Yeah, you can use that, Hanin. Okay, so I'll give you some time to do the download and to organize a little bit lah, the data set and everything. Okay, so I will set up on at my end as well. Okay, I will see you in the 15 minutes time. Okay. Okay, I have added one more. Yeah, this one, the scripts here. You can download this as well. Okay, wait. Okay, you can get ready the, okay, so this is the slides. Okay. And then CD, right? This is the guide. So, okay, so I give you some time to download this and to just, this is the slides that we will be using. And after you install RStudio, it will look something like this, okay? But without the, it will be a simple, just a simple interface, okay? Without all this, okay? So I'll show you step by step on the package installation later. Okay. So, okay, so just a quick check. Do you manage to download the software already? Okay, so all right, let's go through together. Okay, so I'm going to leave this slide as it looks like this. Yeah, so that it's easier to switch from this page to the RStudio, okay, back and forth. Okay, so you can continue, okay, to do the setup, but let me just go through a bit. Yeah, and then we will wait for yeah, everyone like to catch up. Okay, so okay, let's see. Okay. Okay, so this is what we are going to complete it today. Okay, the setting up, and we will cover the data loading lah, okay, before we go for the break, okay, the lunch break. Then after that, we will continue with other modules. So this is the the plan for today. So the first part will be the installation. Yeah, you can use that, Anissa. Yeah, the RStudio in Anaconda Navigator. Yeah, you can use that. Great. So you can install both of them. Okay, you have to install, and then RStudio. Okay, just install. Okay. So your RStudio. Okay, when you open, it will look something like this. Yeah. So once you have your RStudio, you can start installing the packages that we want to use today. Okay, so we will be using TM, stand for text mining, okay, and a few others. So you just refer to the list. Okay, you got this one. You got to use the capital S. Okay, capital S. Sorry. Yeah. So install one after another. So I'll show you where to do the installation. So after you install, you should be able to see some the status are appearing in your terminal. Here. Okay, so let me show you. Yeah, the console here. Okay. So you can go to Tools and then Install Packages. Okay. So in that menu of your RStudio, so you go to Tools, Install Packages. Yeah. So you just type the package name in the box. Let's say TM. So you just write TM and then pick from the list. Don't uncheck this one. Just make sure it's checked and install. Okay. Yeah. So you need to click install. Okay. So I won't do this because I have already installed. So you click install. Okay. So one after another. Okay. How to check whether your package has been successfully installed or not? So how to check? Okay. You can check it from here, packages. So you can view the packages. It should appear in the list. Okay, let's say if you have TM, you can just look up lah. Okay, TM. Yeah, you should see this in the list. Okay, yours may not have a tick yet. Okay, this is when we load the package. Okay, so installation, you install first. For the packages that you need to use later, we will load it. Okay. So just make sure it's in the list. You will also find some other packages like the dependencies of the TM. Okay, So, but basically you will need to see this one, text mining package, and others, maybe the snowball C, yeah, and others. Okay, right. Okay, just a moment, tomorrow. Okay, you go to the menu. Okay, so RStudio, you open up RStudio, then you go to Tools, Install Packages. Okay, yeah. So you go to Menu Tools, click on the Install Packages. Yes, up here, and then just type TM in this space. Okay, just over here, and select from the drop-down list. Okay, select from the drop-down list and click Install. Okay, yeah. So this is the step. Tools, Install Package, enter TM and install. So once you have done with TM, you can proceed with others. Okay. So you can proceed with others in the list. So you can proceed with other packages. For those who have done installing the packages, can you type a 1 in the chat box? If you have done installing the packages, can you type 1? Maybe TM at least, because we are going to start with TM. The rest you can do it during the break. Yeah. If you have downloaded TM, yeah, just type 1, okay? I think warning is okay. Let me see. Warning. Oh, R2s. Okay, basically we do not need R2s. Yeah, for this training lah. Yeah, so it's okay. Yeah, so Muna is okay. It's still okay. So let me move on a little bit. So if you have downloaded the packages, I'm going to show you how to create an R project. Okay. So you can go to the menu again. Okay, so the menu, yeah, here, file. So you go to new projects. So show you from the slide first. Okay. So you go to files, new project. Okay, then new directory, new projects. So create a projects. Okay, you can name any name. So this is example. Text mining, simple text mining. Yeah, you just name any name that you like. You can also select where you want to save the project. Yeah, so after that, just click the create button. So once you create the projects, you will find that there's a project folder. Okay, there's a project folder. Like like this. Okay, once you have created the project, there will be a project folder like this. So you just you can these are manual, okay, manually added folders. You can add the folders manually for you to organize your data set, your output, your source code. Yeah, so this is manually done. Okay, so how to create projects? Okay, sorry, not this one. So you go to File, New Project, New Directory. Okay, New Projects. So you just type your name, the project name, and you can browse to anywhere you want to save. Okay, and then click Create Project. Okay. Once you have created the project, you will find the names appearing up here. Okay. So I have named this project as Simple Text Mining. You will see the project name up here. You will also see the folder. Okay, so yeah, this is this one, the project folder created for you. In the path that you have to look up the path, okay? So this is the project folder. I think you will have one or two files inside, maybe this one. Okay. Then you have to, if you want these folders, this is a manual one, you have to create manually, okay, these folders, okay? Yeah, so basically you will get this project folder only, and I think one or two files inside. And then yeah, you have to create this manually. Okay, so this is the second step, install package and create the projects. Then okay, yeah, I'll give you some time to do that, because after that we will create the R script. Yeah, then we are ready to start the do the coding part. So I'll give you 1 or 2 minutes to create the project, then I'll explain how to create the R scripts. Okay, yeah. So now you have to create the projects. Not necessary to create all the folders. Yeah, it's optional. It's optional, honey. Yeah, it's optional. It's based on your personal preference, how you want to organize. So I just show the path. Okay, yeah, new projects, new directory. Yeah, this one. So yeah. Okay, so the next step, for those who have created the projects, you can proceed to create the R scripts. Okay, which is this one. So it's okay, it's pretty simple. Just go to File, New File, R scripts. Okay, yeah. So just click on the R scripts, and then you just save as a file name. Okay, otherwise it will be the unnamed file. Okay. So I'm going to save my R script in the source folder. Okay, yeah, one of the folder that I have created. So the next step will be to create the scripts. So you go to File, New File, R scripts. Okay. So this is a untitled file. Yeah, this is untitled. So you can just save it. Okay. Yeah, I can just save it. So I will place the script in one of the folder like this. So I will just name the script. You can name the script yeah, with any name. Okay. So I'm going to name the just a file name based on your cohort. Then save. So you will get the extension .r, okay, for this script. So the R script is for us we will be using this file to type the scripts, okay, so that we can refer back later. Alternatively, you can also run some of the commands down here at your console. Okay. So just now there was like okay, one command. Let's say get working directory. Okay, yeah. So if you run this command, you can run it at the console as well. Okay, yeah. So if you run this command, get working directory, it will show you where is your project, which path that you have saved your project. Okay, yeah, where you have saved your project. So it will show you the project path. So you can test the one simple command at the console. So for others, for the command that you in the script, yeah, you can execute that from the script. Okay, so you can here or here. Okay. But of course, at the console, it's like just once. Yeah. So I'll wait a bit at this stage. So if you have done if you have created the projects and created the scripts, you can type number 2 in the chat box. Okay, so that I know where you are now. So if you have completed projects and scripts, can type number 2. Okay, you can type number 2. All right, good. Okay, so the rest, if you have questions, you can just let me know. I will repeat again. Okay. Yeah. So now we are going to proceed. Okay, we are going to proceed. Okay, since we got quite a few number 2. Yeah, this is the checking of a working directory. You can try out. So we will start typing something in the script. Okay, we are going to start typing something in the script. Yeah. So the first thing that we want to do is to load the packages. Okay, so which is the TM package. So we want to load the TM package. So this is the command to load the package. Okay, so you just need to type library bracket TM. So it will load the TM package. Yeah. So we must make sure we have, after we type, we have to run the scripts. You have to run the lines. Okay, so I'll show you how. Go to RStudio. Okay, sorry. So this is my script. Okay. Basically, we want to load the package. So this is one line. Okay. So I have shared some sample scripts with you. Afiq, I think for package loading, you can type in the scripts, okay? Because yeah, so that we have a flow lah. Okay. Yeah. So I have shared the script with you in the e-learn. You can actually download and open it as well using the RStudio. Okay. So this is for you to easily refer to the some of the scripts that we are using. Okay. Yeah. So the first step is to load the package. Yeah, you can also copy from here if you want. But we will go through the scripts one line after another, okay? So that you understand each of the line. Okay, so start with loading packages. So if you want to type some command in R, you have to use the hash, okay? Start with the hash. Yeah. Okay, so load TM. Let's try to load this package. So you can select a few lines. Maybe, okay. You can just, okay. The easiest way is you click on this line 7. Okay, this is line row 7. You click and you click run. Okay. Yeah, so it will run this line. Okay. Alternatively, you can also, sometimes we want to run a few lines. You can also select a few lines and execute. Okay. So when you, after you loaded the package, you can double check, okay? Double check. You will see a tick over here. Just now, this package list. You see the package list on this side, the lower right. Okay. So you can type TM. There will be a tick here. Okay, your lower right in your screen. So that is after you loaded the package. If you haven't loaded the package, there's no tick. So you will see a tick over here. Okay. Yeah, so this is for you to check okay, whether the package has been loaded or not. Okay, so load the package first. Let me see what's the next step. So from time to time, you can load other package as well. Yeah, you can load other package as well. Yeah. Okay, so we want to look at how we can load the data. Okay, how we can load the data. Okay. Activity 1 is for you to collect the data about your tourism spot. You can do it later, this one. Yeah. Yeah. So we are going to proceed to load and view the data. Okay, load and view. The functions that we are going to use to load the data is the corpus functions from TM package. So that's why you must load the TM package. Okay. Very easy, just one line, but you must make sure you put the correct path, okay? Yeah, because you may have a different path. Okay. So this is the line to load the package. No, load the data. So what the corpus function do is it will load the data in text format. Okay, we are going to start with the one in text format. So in the folder, there must be a series of a set of text file. Okay, yeah. So what we are going to what I give you over here is the data set. There are 2 sets. We will be using the first set first. Okay. So what you need to do is to unzip it in the one of the folder. Okay, so remember to unzip. So once you unzip, you will get a list of 10 text file. So this is how I arrange it, like one file, one review. Okay, one file, one review. So 10 text file. Okay, so this is the place where I place all the text file. So in my RStudio. Okay, I'm going to load. You can refer to the script. So load data. Yeah. Okay. So just make sure the path is correct. Okay, make sure the path is correct. And I think another thing to take note is the slash. You have to put a forward slash here. This one, a forward slash. Okay. So this functions, corpus function is going to load the data from your text file, and it will create objects called is corpus object. Okay. Okay. And yeah, the sign here is to assign the output to that corpus object, but you can name it. Okay, so this one is flexible on the left one. This is how you can name your objects. So I name it as docs. Okay, so let's run this. So this is the second step, load data. I'm going to run line 14. Okay, click on 14 and I run. Okay, yeah. So after you execute a line 14, you can check. Okay, yeah. How to check? So you can actually view by okay, two ways, a few ways to view lah. Okay, maybe I show this one. One is the summary of the object. Okay, so view data. So you can view the information about this corpus object. Okay, you can actually just click on these docs, or you can type here. Okay, you see line 20 is the docs, calling back the docs object. Okay, this is the calling back the docs object. If I execute line 20, okay, so this is the summary about the objects that I have created. Okay, so we still cannot see the contents yet. If you look at summary, you can click summary 21 and run. Yeah, so it will show that there are actually 10 files being read in the summary. Okay, and if you want to display the contents, we have to use these two functions, write lines as character. Okay, display as character. And you have to specify which document you want to see in the array, because just now when these corpus functions load the 10 text file, it places them in an array. Okay, if you execute line 24, I want to look at the number 1. Okay, so yeah, this is my text file. Okay, that has been loaded. Okay, so you can double check. Is this number 1? Okay, yeah. So always counter check. Okay, always counter check the data that you have original one and the one you have loaded. Okay. Let me see. So Afik, you got the empty directory. Can you check the directory whether you have the text file inside? Because I think it's empty. Yeah. Do you have this path? Because this is the path that I created at my end. I have placed the project in R. Yeah. You must make sure you just need to put the path that you have placed your data set. So where did you place your data set? Okay, so because this is my path. Okay, yeah, you need to change the path. Yes, this is the path where I place it in the project simple text mining project folder. Then I have created a data folder. Then I place it in this folder. Okay, it's here. So you need to change the path. Okay. So yeah, you try. Okay, the rest you try. If you can view the data, load and view the data, can you type 3 in the chat box? Okay, Hanin, you got this error, could not find function corpus. Can you check whether you have loaded TM package? This one? Have you loaded? Loaded means you have executed it. Where is it? Okay, you have executed it. Just now you have to run it lah, from this line. Okay, and also, okay, you can double check at the package list over here. If you look for TM, you should have a tick. Okay, you should have a tick. This one. Empty directory. Empty directory. Okay, already. Okay, wait, this is a different one. Yeah. Let me check with Hanin first. Hanin, do you have a check beside your TM package? Do you have a tick sign? If you get working directory, right, for Muna, do you have this same do you have you created the project? Like, do you have this like project name up here? Okay, now okay, all right, good. Yeah. So you try again, Hanim. Yeah, it should be once the package is loaded, you should be able to access to the corpus function. Yeah. So yeah, let us do this for another 3 minutes. Okay, later we go for yeah, we can come back later a bit after lunch hour. Just a quick check of any issues that you have. But if you have anything, we can troubleshoot again after lunch break. Oh, okay. Right. So if you manage to load and view the data, can you type number 3 in the chat box? Okay. Yeah, I think, okay, at least it works. Okay. Yeah. All right. So the rest, please continue until these steps. Okay. Yeah. So you need to, I think some of you probably still installing the packaging packages and also placing the data set. So to take note, yeah, just I'm going to repeat again. You need to place your text file correctly at a certain path. Okay. So for mine, I place it at this path. Okay. I place at this path. And then you need to change the path accordingly. Okay. Yeah. Unless you place exactly the same as mine. So you change the path accordingly. Remember the slash should be a forward slash. Okay. Then this name, you can assign any name. Okay. Yeah. Yeah. Then you can try to view. Okay. Try to view. So this is the first one. You can also, maybe if you want to view the second one, yeah, you can save the data outside the R folder. Yeah, this is the second one, longer one. Yeah, you can say just the when you specify the path, just make sure it's the correct path pointing to the data set. Okay, so I think we can go for a break. If you have any question, we troubleshoot when we come back. Okay, yeah. So let me stop the recording. Okay, hello, welcome back. So are you ready to continue? All right. Okay, so yeah, if you have any questions, can you maybe just quickly share at the chat? Yeah. So we will address it first before continue. So in case you have any question, like with the data loading, yeah, can you type at the chat box first? If not, yeah, we will proceed. So can you see my screen, the RStudio screen? All right. Okay, good. Okay, in that case, we continue, okay? We continue, right? Okay. Okay, so we will continue with the text preprocessing. So for text preprocessing, we will be using the a few functions that come with the DM package. Okay, yeah. If you want to check out the functions, so you can just try using the, okay, you can just type the get transformations command. Okay, so this will actually it will display the functions that you can use. Okay, so there are actually 5, 1, 2, 3, 4, 5. Okay, so if you want to check out this, you can type it at the console. Okay, so you can just type add transformation. Okay, so here. Okay. So yeah, get transformation just to display the functions that you can use. Okay, we are not applying it yet. So this one just show you the functions that you can use. Okay. Right, let's go back to the slides. Okay, so before we apply the text preprocessing functions, we want to go through one step to clean the text. Okay, so this step we will be looking at one issue, which is okay, it has to do with the issue when we perform the remove punctuations functions. Okay. So there's a part in the text, okay, where there are two words connected with a hyphen. Okay, so you see this one. Okay, so for this connected, okay, if we have this kind of words, right, two words connected together with one hyphen, what will happen after remove punctuation is both words will be joined together. Okay, yeah. So this is a part where we want to try out the regular expressions, where we remove, no, not remove, we replace the hyphen with a space, okay? Yeah, to avoid these two words to be being joined together later. Okay, so what we are going to do is we are going to do a little substitutions on the text. Okay, just to replace the hyphen with a space. Okay, yeah. Okay, so once we replace with a space, yeah, we can proceed with punctuations later, remove punctuations later. Okay, because basically the space will be gone lah. The space will be there lah. Okay, separating two words. Okay. Okay. So in order to do this, we will create a new function. Okay. So the new functions, the name of the new function is called to space. Okay. This name you can name it any name. Okay. Yeah. So the function will take in two input. One is the X and the other one is the pattern. Okay, X is your text. Pattern is the pattern to search for. Yeah. So that means okay, this function we can actually pass any patterns to replace to become a space. Not necessary only a dash. Okay, the hyphen. Okay, so the it's going to take in any patterns, and what it's going to return is the it's going to perform the substitutions. Okay, so it will substitute the pattern with a space. Okay, in your text. So this it will return the outcome. Okay, yeah. So we will create this function first, and then followed by applying these functions to your corpus object. Okay, so you will create it and then apply it to the corpus object. Okay. So you can see here, we can actually we can input any pattern. Okay. So later on, you can try using other pattern as well. If there's anything else you want to clean, you can do the replacement of the hyphen over here. Okay. So let's proceed to create the function first. Okay, so the first step, okay, text preprocessing. We create the functions and do the mapping. Okay, so these few lines. So basically get transformation here is not going to apply any preprocessing functions yet. Okay, just display only. Yeah, so I think here this one we can just remove that. Okay. So line 31. Okay, line 31, we will create a function. Okay. And then okay, let's run this line 31. Yeah. After you create the functions, you should be able to find the functions on your right side. Okay, so this is a place where you can actually view and check the objects that you have created. You know, it's in the list. Okay, so for example, this function is called to space. Okay, you will find it over here. Okay, yeah. Okay, if you notice, these to space functions, right, it's not listed under the list down here. Okay, it's not listed under the list down here. It's because when RStudio is trying to detect these functions, it is okay. This function is actually being wrapped using another functions from TM package. That means this particular functions will functions as a content transformer functions. Okay, that's why we cannot see it under here. But in the future, for other functions that you have created, not wrapped under any of other functions, you will see it right here. Okay, yeah. Okay, so yeah, so this is the functions that you have created. You can apply it. Okay. Okay, how we are going to apply is we are going to use the TM map. Okay, this is a functions by a TM package. It will apply the to space functions to the corpus objects. So it will actually run through the whole array. Okay, it will apply to all the uh, uh, the rows in your array. Okay. One thing that you can do is to view the okay, you can view the text before you apply this. Okay, so okay, just now we talked about this one, right? This particular text has this hyphen. Okay, and I think the hyphen also appears somewhere else in other texts as well. Okay, this is number 3 lah. Okay, so what you can do is you can view the text first. Okay, you can view let me just view it. It is number 3. Okay, so I'm going to view the content before before the removal. Okay, so here, okay, let me run. Okay, yeah, just to verify that this is there. Okay, so when I run this line 34, I have this yeah, you can see this family hyphen run. Okay, yeah. Okay, then after that I'm going to apply the this line. Okay, I'm going to run these functions. 37, line 37. Okay, let's run it. Okay, so after that you can view again. Okay, so so we have run 37. This should be removed lah. Okay, so I'm going to view the contents after removal. So you can also actually go back to click 34. Okay, if you want to run 34 again, this line 34, you can click and run. Okay, yeah, it's gone. Okay. But the way you arrange the scripts, normally you have to follow a sequence so that you can, although we can go back to any lines to rerun, but you have we will follow a sequence so that you can execute them once, okay, if you need it from beginning to the end. Okay, so okay, if you want to run again to verify, okay, so this is how you can do it, or you can have another line if you want to display before and after in the script. So this is gone. Okay, you have done the removal. Okay. Using the same functions, you can remove other symbols as well if you want. Okay, so for example, just now I noticed that, okay, I'm seeing this thing. Okay, you can see this. Yeah, this weird symbols. Okay, this is supposed to be a quote. Okay, yeah, and I think this one happens when I copy the review from the HTML page to the original website to the text. Okay, where it was like interpreted as a specific type of these codes. Okay, and this also. Okay, so you can remove this if you want. Yeah, so let's say I want to remove this this pattern. Okay, let me copy. Okay, and I do again the removal. So instead of to space, so I'm going to, okay, maybe like this one. I'm going to remove additional noise, okay, from the text. Okay, So my additional noise is this one, open bracket 92 and close. Sorry, close. Okay. Yeah, this one. Yeah, so this is the part I'm going to remove. Okay. So let me run this line. Okay. So you can proceed to do other kind of other cleaning as well if you want. Yeah. Okay. So let's say we are done. Okay. Once you are done, okay, let's move on. This is the, wait a minute, okay, remove hyphen. Okay, so you can proceed to other text preprocessing steps. Okay, yeah, so you can proceed to remove punctuations. So using back the same objects here, yeah, you can apply remove punctuations. So you can also compare before and after. So this one, the punctuation should be removed. Okay, this is the, yeah, this is actually the issue with the code. Yeah, but with the current corpus objects, it is like, it is converted to that number. Okay, so you can convert to lowercase. Okay, convert to lowercase and remove numbers. Okay, remove numbers. Yeah, so we will try all. Okay, yeah, we'll stop there first. Stop, but we will come to it later. Okay. So remove punctuations, okay, and then remove numbers and remove the this to lowercase, change to lowercase. Okay, so let's do this tree first. Okay, we do this tree first. So additional one, you can look at the, yeah. So this tree, 1, 2, 3. So before you apply these three steps, you can just do a quick check at the on the current text. Like, okay, here you see that, okay, we got the ampersand, you got a semicolon, you have a quote, comma. Okay, all this should be removed. Okay, so let's try to run line 43. Okay, so every time, okay, when you see this reassign, right, so every time after you apply the functions on the corpus object, we are actually reassigned back to the same objects. Okay, so that means it's going to replace the corpus object with the clean version. Okay. So let's run for this tree. Okay, for which you can select and run. Okay. So you can view again. Okay, just to make sure the punctuation has been removed. So you can view. Yeah, maybe again, this one is view. Okay, I'll type this at the end. Okay, view contents. Maybe after text pre-processing. Okay. Yeah. So I'm going to click here, this one again. Yeah, if you see the text, the punctuation is gone. Okay. Yeah, the punctuation is gone. Okay. So let's proceed to lowercase. Okay, so make sure there's some uppercase here that you want to counter check. Okay, so they would later you will see all these become lowercase. So okay, 46. Okay, 46. So lower. Okay, right. Again, I'm going to repeat this. Check the text. Okay, run again. Yeah. So we should see all being changed to lowercase. Okay, and then one more step. Remove the numbers. Okay. line 49, remove numbers, and run. Okay, remove numbers. So, okay, this text doesn't have, it doesn't has a number. Okay, you can find one with the numbers, which is this one, number 2. Okay, so we can check again. You can check number 2. This one. The text in the number 2, okay, in our array. So number 2. Okay, let's run. Yeah. So make sure everything is done lah. Okay, after your this up to this pre-processing step. Okay. So far okay, so far so good. Are you able to process up to this stage? Right. Okay. Yeah, you can just show me a sign. Yeah. Or yeah, you can type the feedback in the chat box. Okay. So the next step, you can see that we still got many words here, right? Yeah, just now we talk about words. You still got many words in the text. So we are going to perform the stop word removal. Okay, next step will be stop word removal. Okay, so remove stop words. Okay. So we will be using the remove words functions and call the stop. We call it stop list or stop word list that comes with TM package. So this is how you can call the stop word list. Okay. So because this is an English text, so we will be using the English stop list. Yeah. And these are the words. So let me see. This is before. Okay. After, you should have much less words. But let me show you the list. Okay. I'll show you the list, which is you can find in this file. Okay. Go to the yeah. So this is the word list. Okay. Stop words from TM package. They have a few. They have a few additional languages lah. Yeah. So these are the languages covered. Yeah. If you are processing text for these languages, you can call their stop list. Okay. English word list. There are a few. You can call EN. This EN word list is the stop list produced by this project, Snowball Stammer project. Okay, yeah. And there are other stop lists as well. So if you want to take a look at the word list, you can type stop words bracket EN or English. Okay, so you can see the full list. Okay, so down here you can actually type the stop words. Just to display so that you know what will be removed. Okay, so this is the stop list. There's also another stop list called Smart. Okay, I think it's this one. This one has more words. So whether the coverage of the words in the word list actually it depends on the purpose of why the stop word is or how the stop word is being built. Yeah. So if you see this one, it has more words, and you can see there are some words which is quite not exactly English words, but you can see this is got co, got com, yeah. And the reason is because SMART is a stop list from built from the information retrieval project. Yeah. So for information retrieval systems, right? Many of the words are from website. Okay, so the website's words you can expect like they are something.com, So if you tokenize, then That's where the like comp, you can see those specific words. Okay. So this is the stop list. So you can apply this. So you can do is you can remove the stop word. So for now, we will use the standard list. Okay, so we are going to remove the stop words. So before we do that, we take a quick look. Okay, because this one now we can we want to view the text again. Okay, let's see this one. This is number 2. Okay, I'm going to remove the stop word now. Okay, line 57. Okay, run. And let's view again. I'm going to click on this line again. Okay, line 54. Run. Yeah. So you can actually try to just check the text above and the text down there. Okay. So many words have already been removed. So now you get a shorter, more compact text. What if you want to remove more words? If you just read along this, right? Maybe we think that okay, now we want to remove maybe us, or maybe just the s, or you want to remove like others, yeah, any other words that you want to remove. You can create a word list. Okay, yeah. So okay, let me so this script has a word list here. Okay. Okay, if you want to remove additional words, you can create one word list. Okay, yeah, you can call it a customized stop word lah, your own customized stop words, and you can create the list like this. Okay, yeah, there are 2 ways. One is you just list, if it's only a few words, you can list it like this. But if it's a long list, you can actually put it in the file. Okay, put it in a text file. Okay, let's try this one first. This is the we create first. So what else do you want to remove? You can list over here. Okay, you can list over here. Okay, let's create the custom stop words. Okay, run. Okay, you should be able to find in this column. Okay, let's look at the custom stop words. Okay, yeah. If you want to take a look at the the list, right? Okay, custom, not this one. It's the custom dot stop word. It should be down. This is another list. It should be somewhere down. Value, yeah, this one. Yeah, okay. It has a list of 3. Okay. Okay. So you can apply it when you can use the same function, but just call the word vectors. So you just call it line 61. Okay, let's run. Okay, so these few words should be removed. Okay, you can double check. Okay, in case you have a long list, then you can place the list in a text file. I've got one example here. This one you can try out. Yeah, you just place the list in a text file, 1 word per line. Okay, 1 word per line. Okay, then you can read from the text file. Okay, so let's say your text file name is custom.word.txt. Okay, so you can read read from the text file into a table. Yeah, and then you just apply apply the column from that data frame. Okay, you just apply. So you just apply this word list. So it's very flexible lah. That means anytime you can, whenever you can get one word list elsewhere, you can just import it, okay, and apply. So after you have done the cleaning, okay, one more, this is just to tidy up your text. So if you run this, strip white spaces, it will remove the extra white spaces. Okay, if you have more than one, it will remove. Okay, we can do this as well. So you can, actually this one, the last, before normalization. Okay. Can remove the extra white spaces. So I'm going to put the infection, copy the infection down here. So line 61, okay, let's run this one, run. So view again, review the contents after text processing, preprocessing, okay, 6. So it just remove the white spaces, okay. So now we are done with the removal, the cleaning part. Okay, that's okay. The next step will be the normalizations. Okay, the normalization. We still haven't done the normalization yet. Okay, yeah. Okay, so we will proceed, okay, to perform normalizations on the words. Okay. So we will try both stemming and lemmatizations. Okay, so there are two, so we will try both. Okay. For stemming, make sure you have downloaded the package, Snowball C, this one, and we need to load the package. Okay, so this is stemming, and also the lemmatizations. Okay, we do one by one. Okay. Okay, so we are going to proceed with two paths. Okay, we'll try stemming lemmatization. So what you can do is, because we still want to retain we want to try out using the same objects for two different methods, right? So in this case, let's duplicate, okay? Duplicate the object to try for stemming and lemmatizations. So you can just name one as this one and the other one as dot lemma. Okay, so this is one. So you duplicate the docs object, okay, the corpus object. One for stemming purpose and another one for lemmatization. So after that, you can just call okay, remember to call the correct objects and apply the stemming functions. So let's continue with the stemming. So this is the text normalizations, okay? Duplicate and then, okay, probably again all here. But before that, remember to load the package. Okay, so let's go all the way back up. Okay, remember, need to load Snowball C, right? Yeah. So this one. So let's remember to execute this line. Okay, line number 8, Snowball C. Okay, run. So after you load the package, okay, you can come to the normalizations. Okay, and then remember to also duplicate the object. Okay, duplicate. So I'm going to duplicate both at the same time. Run. So you should find these two objects appearing at this window also, like, yeah, lemma and stem. Okay. So after that, you can perform the stemming. Okay, you can perform stemming. So let's run line 76. Okay, 76 is this one. After that, we can, okay, let's do a check. We want to check the output after stemming. Okay. Okay, so remember to change this because this is dot stem. You have to change this to dot stem. Okay, this is the, yeah, so you got this dot stem. Okay, let's take a look at the outcome. 78, okay, 978. Yeah. So can you compare? This is before stemming, this paragraph after stemming. We just take a quick look at the words. What are the changes that happens to the, happen to the word? And can you name some funny words that after stemming, what are the funny words do you see from the, from the result of the stemming? Yeah, so it actually in lines with the rules that we have seen in the morning. Yeah, you see the animal also become like anim already. Yeah. Oh, the skip A is like that is not the stemming fault. It's because just now we got one part in the uh in the, I think in the raw text that we didn't treat that. Yeah. After remove the punctuation, I remember there was like a bracket A0, then close bracket. Yeah. So that one, after we remove the punctuation and I think the 0, it becomes like the A and skip join together. Yeah. So so Anissa, so this is the part that we need to actually, when we discover all this, right, at these steps, later we have to go back to improve the pre-processing pipeline. Okay, become lady, yeah. So, okay. So the ladies also become the ladi already, yeah. So this is the output of the stemming, yeah. But still stemming is being used heavily in information retrieval. Okay, so let's try lemmatization. Okay. So for lemmatizations, you will need the, okay, this is the stem output. Yeah, you will need to load the stack stem library. Okay, we need to load this. Then, okay, let's go back up here. So you can actually add your comments. Okay. So you want to load the exam package for lemmatization. Okay, library exam. This one. Run. Okay. So continue with the lemmatization, line 86. Okay, so run. Let's check again. Okay, this one. Check the lemmatized output. If you want to check the lemmatized output, you have to, okay, just remember to change this. Okay, so 88. Run. Okay, now you can compare stem and the stamped output and the lemmatized output. Okay, you can compare them. Yeah. So if you see the lemmatized output, you get the animal, right? Yeah, you get the just now the word that you have listed. What about ladies? Does it? What happened to the ladies? or this, it become lady, right? Lady. Yeah. And there are some past tense also. Yeah, you check out the past tense. I think previously there was like got past tense. Bought. Yeah, you can take a look at bought, like came, declined, handed. What happened to these words after stemming? Okay, so yeah, just take a quick look. So at each step, we will do inspection lah, okay, so that we understand what is going on, okay, from one step to another. All right, okay, done with lemmatization. Okay, so this is the lemmatized output. So same thing, activity 3 is for your own data set. Yeah. So later on, you will need to collect your own data set and repeat the same steps. Okay. Do you have any questions so far? Anybody like need to troubleshoot? So we can just wait for a moment for this troubleshoot. Okay, wait. Okay, let me see. After you load the package library, I think I also have the same message. Are you able to stem, Muna?
When I stem, the ladies still remain as ladies.
Okay, ladies still remain and not stem, lemmatized, sorry.
Yeah. When I run the lemmatized function, then I don't get like you say ladies become lady, right? But mine is still maintained as ladies.
Oh, okay. Can you check your lemmatized step? Your input.
Yeah, this.
The input is docs.lemma, right?
Yeah.
When you print out, do you print out the docs.lemma?
Okay.
I think you print out the stem output.
Okay, thank you.
You check again. Okay. Oh, Afiq, your lemmatized is different than mine. Okay. How different? Oh, same issue. Okay. Oh yeah, just take note lah, because just now we got two objects different. Yeah. Just remember lah, this one lah. Okay. Yeah. This is the you are viewing the lemmatized output. This one is the stem output. Okay, so two different now you got two different corpus objects. I think you should be able to see this. Yeah. Okay, what about the rest? I didn't heard theirs is just displaying problems only. Anyone want to troubleshoot anything? Okay, if no, okay, if no, maybe we continue. Okay, we continue. Okay. Okay, so now our text is actually ready lah. Yeah, I think we regard this version as ready for the next step. We have lemmatized, we have normalized, we have removed the words that we don't want. Okay. So let's move to the next step. Okay. on how to represent the text. So next one, let me explain a little bit. So up to now, the text that you are having is still in a one long text form. It's like one piece lah. It's still one piece. Okay, and then although I think that during lemmatizations happening at the back end, they still need to detect your tokens. Okay, but that one is happening behind the scene of the lemmatizer or spammers. Yeah, but now but the output that we are having now is still one long text. Okay, yeah. So the next step will be we want to represent this text as words. Okay, so that is this is where our document terms matrix comes in. Okay. So we are going to use the DTM, okay, to store or to represent the words in these collections. Okay. So in the DTM, it is a matrix. You have a column and you have rows. Okay. So okay, the column you will have a column is your terms, okay, or your words. So you have words in the column and document as rows. There's another version. TM has two versions, either DTM or TDM. Okay, in the PDF file, you also will see TDM, just that the orientation is different. Okay, yeah. So, but for now, we will start looking at the DTM first. So you have the term as column and document as your rows. And the cell in your matrix will be, you can represent, okay, there are different informations like what we are going to look at today is the cell will represent the frequency, okay? Frequency of particular words in a document. Okay, so if the word appear one time, it will be recorded as one. If the word occur like 2 times, 3 times, it will appear as that number. Okay. But next week, what we are going to see in the cell is a weight. Okay. Yeah, we will be using the simple weighting method called TF-IDF to we will apply that to weight the terms or the words. Okay, but this week we are still going to use the raw 1, 2, 3 lah, because we want the count. Okay, so this is how it looks like. You will get the words in the column and the documents in the row. Okay, so the dimension can be very huge because there can be many words. So if you can recall, this is the word type, okay, the distinct word. Every single distinct word, you are going to get one column, okay, and your rows also can grow because it depends on the size of the documents in your collections. For now, we only have 10 lah. What if you have 1 million? So the row also can be very huge. Okay, and there's also an issue of sparsity. That means that if the DTM become very huge, right? There very often it's because the most of the words only appear in maybe one document only. Yeah, it only occur in one document. The rest you will actually record 0. Okay, yeah. So we have a sparsity issue. Okay, but let's try to create the DTM. Okay, first. You can choose, okay, here you can choose whether you want to use the lemmatized output or the stem output. Okay, you can choose which one that you want to use. Okay, I will use lemmatized output lah. Okay, the output of your DTM, the matrix. Okay, this is the name. You can name it anything. So here we name it as DTM. Okay, after you create the matrix, you can view the summary of the matrix. Okay, you can view the summary. Okay, then you can also inspect the matrix. Okay. Okay, so let's go to the R Studio here and we talk a bit more about DTM over here. Okay, so here so let's do the inspection. Okay, this part. Proceed with docs.lemma. Okay, I'm going to proceed with docs.lemma. And then to create the DTM. Okay, so by the way, DTM, the document term metric is the functions of a TM package. Okay, so this, okay, let's create DTM. Okay, run. So it's here. You will find your DTM created here as well. Okay. Next, you can view, okay, the summary. So this line, okay, you can run. Okay, what does this summary tells you? You have 10 documents and there is a total of 291 terms or words. Okay, this is your distinct words. Okay, yeah, this is your word type. If you want to calculate the raw words, tokens, because now we have already cleaned and normalized and everything, right? So based on this is our words left. Okay, the distinct words left. But if you want to count the original token, oh, okay, maybe that way is the word types. Yeah, you can take the raw one. You can also create a DTM for the raw data, yeah, so that you know before and after cleaning how many distinct words that you can actually remove. Okay. So okay, you can do the inspection. Okay, run. Yeah. Okay, so now you got the words here. Okay, this is a sample. If you just inspect DTM, automatically there's a sample. This is the sample will be displayed. Okay. Yeah. So if you look at this one, so here you can actually see that goat, it appear in certain text how many times. Okay, you can see that how many times goats appear in text. Example, this one or that the other one. Okay. Let's go back to this. Okay, what does it mean by the sparse versus non-sparse entry? Yeah, over here. Okay, so the entire matrix, it will have 291 times 10 cell, all right, 291 times 10 cell. Okay, out of this 200, so you got a 2910. Okay, out of this, right, the sparse entry is very high. You see, it's like 2454. Okay, yeah, so it's 84%. So that means this number of cell is actually zero. Okay, it's actually zero. Yeah, only this number has an entry. Okay, so this actually shows the sparsity of your of the matrix. Yeah, your number could be like one or two difference lah with mine, because that could be the cleaning steps that you have taken. Maybe I have removed some words, I've cleaned some things. Yeah, so it will be like slight different. Okay. But I think your total terms should be more or less the same. Like it won't run that much. Yeah. Could be 289 or maybe a little bit more, a few more. Yeah. Should be around this number. Unless we we use exactly the same step, then we can get the same number. Okay. So far, this is still a rule-based. We follow rules. So if you do exactly the same step, we are going to get the same number. Okay. So next one. So over here, I think, okay, if you want to look at the other parts of what about other words? Yeah, so you can actually inspect the DTM by calling a certain rows and column. Okay, let's try this one. Let's see, 102. Okay, yeah, you just inspect a certain portion. Okay. Okay. So, but the calculation here is actually just based on these 50 cells. Okay, here is like 10 times 5. Okay, so it's based on this 50 cell, the sparsity. So you can actually view other sections, because every time I think maximum it's 10, right? 5, 6, yeah, 10 only, yeah. Okay, so inspections. So let's try a bit of okay. Let's proceed to the text mining part. So now we already have the DTM. Okay. So the first step is okay. We want to do some counting of the words. And if you look at the DTM just now, we already have some counts for the individual rows. Okay. But now we have to do some addition lah. Okay, we need to add up. Okay, we need to add up. Okay. Fahmi, yeah, sure. Yeah. Okay. So right. Okay, next one. Yeah. So we want to know the frequency of the words. Okay. Yeah, this is the first step towards the counting. Yeah. So we want to know, okay, which word actually appear more frequent than others, so that we can pick the top words. Okay. So okay, we can use the DTM and just do a summation. Okay. So the functions used will be the column summations. We are going to sum up the numbers in the column, and the output we will assign. Okay, we'll assign to a vectors of these frequency vectors. Okay, so you will do the summations. Yeah, and then the length should be the same because how many words we are going to total up all the for each of the words. Okay, we are going to total up for each of the words. Okay, and then followed by the ordering. Okay, yeah, we have to sort it so that we can see which one is the most frequent to the least frequent. Okay, so we will use the ordering functions to sort. Okay, to do the sorting. Okay, after that, then we can inspect the head and the tail. Okay. So this is how to get the frequent word list and the least frequent list. But again, the least one will have many because there are many words that only occur one time. Okay, so there will be many words with the occurrence one. Let's try out. Can just try out this part. Okay, so you already have the DTM. You can perform a column summations. So here you run it. So just to counter check, you're actually having the same set of terms. So it's 291. Okay. Okay, you can order them. Okay, you have to order. So there's a parameter for you to set. Okay, whether it's from ascending equal descending equal true or false. Yeah, so you can set and yeah, with that, okay, if you can see the ordered sequence, yeah, it's over here. Okay, basically it will order the terms, okay, based on the counts. And if you want to inspect, okay, let's take a look at the head. Okay, let's say the top 10 words. Okay, top 10 words. So you can run. So you are going to get the word list, like goat, farm, and so forth. Okay, and the count. Yeah, so you get the word list and the count. So for now, it's one word. Okay, you can try with the ngrams tokenizer. I think I have shared the scripts. Yeah, I have shared the scripts. I'll show you where to do it. Maybe end of the day or maybe next week. Yeah. So the for now, what we get is like only one word. Okay, one word for now, and the count. Okay, the frequency. Okay. If you look at the least one, okay, sorry, the less frequent word. Least frequent word. Yeah, basically we are getting those one count, but there are many one counts. Yeah, there are many one counts. So whether the one count is really important or not, yeah, so this one we have to decide. Okay, we have to decide, yeah, whether you want to keep or not keeping it. If you don't want to keep it, then we have to actually reduce the or find a way to remove this of the these words. Okay. The issue with one count words is it's going to make the dimensions of the matrix very big. Okay, just imagine like if you have just one count, that means like for example this Uber or maybe the refresh. Okay, this word only appear in definitely one count. It only appear in one document. Okay, the rest of the 9 document it will record a 0. Okay, it will record 0. Okay, so we have to actually if weigh whether okay are we still keeping this word only one time in one document. Okay, yeah, so this is the part where we are going to look at in the dimension reduction part. Okay, so for now we can actually get the top list and the least okay, and the least the lowest one. So the subsequent part, okay, the next part, right, we are actually going to look at the dimension reduction. Okay. But okay, let's take a break first, and then we continue with the dimension reductions. Okay, is that okay? Yeah. So you just try up to this stage first, representations, and then get the top list of the words. Yeah. So when we come back from break, we will go through the how to reduce the size of the matrix. Okay, how to reduce the size of the matrix. Yeah. Yeah. Then we will perform the text mining again lah, and the plotting. Okay. All right. Okay. So let me pause the record. Okay. Okay. Welcome back. Right. Okay. So shall we? Yeah. Continue. Okay. So just now we talked about the large dimensions of the matrix. Okay. So yeah, we will be looking at one method that you can use to remove some of the words, okay, that which is not so important in the matrix. Okay, so the idea is to look at whether the words maybe occur very frequently in documents or not. Okay, so that is one factors lah. Yeah. So okay, let me start with this one. Okay. If you okay, so let's take a look at maybe a particular word. So the word, if it's a particular words like right in the collections, it can either appear in large fractions of documents. Okay, that means words like maybe goat, it appear in many documents. Okay, so we will use the fractions or ratio. Yeah, we cannot use perhaps we cannot use the count because we don't know how many times the words is going to occur, but we can estimate either using the percentage, or if we know the total documents, then we can set the document size. Okay. So if let's say if the words goat appear in so many documents, the idea here is it may not be specific enough, okay, because it occurs in so many documents. That means every document will mention it. Okay. That will make the okay, DF, okay, there's a factor called DF, document frequency. Yeah, okay. So this will make this particular DF very high. Okay, so this is the DF. Yeah. So let's say maybe for a word goat, the DF is very high. It occurs in, let's say, got 10 documents. Maybe it occurs in a 9. Okay. Yeah. So in the idea of specificity, this kind of words like is we say that it's not specific enough because since every document mention it, so if you let's say if you pick that as a keyword, okay, if you pick that as a keyword, let's say goat is a keyword, and I'm going to put forth this keyword in your dashboard. Okay, so basically that keyword is going to link to all of the documents, right? Almost all of the documents. So that makes it like not a very good keywords. Okay, so this is an idea. Yeah. But then at the other end, if a particular words occur in very little fraction of documents. Okay, just now we got like, I think one word, like maybe refresh. Okay, so the DF is very low. So out of 10, it occurs in 1. Okay, yeah. So it's so low until we also think that, okay, it's not that important. Okay, yeah. So we can use this idea to help us to remove some of the words in the matrix. Okay, next page. So this is what we are going to do. When we create the document term matrix, we are going to set a setting, okay, saying that, okay, the first setting is about the we are going to set the bounds of the documents, okay, the DF. That means if a particular term occurs in between these two, okay, 2 to 8 means between 2 documents to 8 documents, then we are going to include it in the matrix. Okay, otherwise it will be discarded. Okay, so that will be the one setting. Okay, that particular words, it must make sure it has something in the it cannot have like more than 8. Okay, that means if you have entry in the 9 cells in the column, so it will be discarded. Okay, or it also cannot have less than 2. Okay, yeah, one yeah, this will be discarded. Okay, so this is the one setting about the DF. This part also has another additional setting about the length of the word. Okay, if the length of the word, the character has to be between 4 to 20. If it's too short, like two characters or 3 characters, so this word will be discarded as well. Okay, so these are the two criteria set, okay, to help us to reduce the size of the document term matrix. Okay, so we will create another one, another DTM, and we call it as a DTM.tr. Okay, we call it DTM.tr. Okay, so next. Okay, so we are going to repeat again lah. Okay, after after we create the DTM.tr, we are going to perform the inspections first, and then proceed with the text mining. Okay, so let's take a look at another version. So this part. So you are going to create another document term matrix with the term reductions. Okay, yeah. So let's create the matrix, and then you can display the TR. You can display, and you can also inspect. You can view the summary. Okay, so yeah, can you see the number of terms here? Previously it was 200 over. Okay, now it has been reduced to 69. Okay, sparsity lower a bit. Oh yeah, just now was 84, so now the sparsity it's been it's lower lah. Yeah. Okay, let's do the inspection. So what are the terms size do you have? Yeah, what is your term size now? Mine is 69. Yeah, after you remove the reduce the dimensions. So what do how many terms do you have now? Okay, you got Aniza, you got 71. Okay, Muna 72. Okay, I think around that lah, around that lah. Depends on your original the previous term size also. Yeah. But if you check at if you just check your sample, goats should not be there. Okay, goats should not be there anymore, and the rest of uh, the terms that occur one time only, they will be also removed. Yeah, that's why we have a very huge reduce of the number. It shows that during the first round, we actually have a lot of these terms that occur one time. Okay, so now we have a much smaller matrix. Okay, we have a much smaller matrix. So we can repeat the step to total up, okay, the column. Okay, so you can review back the previous this one, the previous sections. Okay, maybe this is this is a DTM dimension restrictions. So 7, and then you can check the word list again. Okay. Okay, so here you have to change that. Okay, make sure you change to the .pr. .pr just name as the variant and then change the outcome of this one frequent .tr. Okay, remember to edit this. So when you do the ordering, so order on the new one. Okay, if you want to view, okay, view the TR. Okay. Just remember to rename. Okay. So just repeat the process again. Okay, just repeat again. Right. So I'm going to, okay, after that you can run it. Say this one. And then you can check, okay, you can create the sort order. Okay, after that, we can just view lah. Okay, view again the top 10. So if you view again the top 10 words, you are not going to find the goat anymore. Yeah. But actually, I think farm also occur quite a number of times. But it depends on the just now the criteria that we have set. Yeah. Farm occurs in 7 documents. Yeah. So basically, because this is a review about goat farm, so yeah, eventually farm also I think should be removed. There's these keywords. Okay, the tail part, okay, what's the tail? Yeah. So if you look at the tail, the list, now you have those occurring 2 times. Okay. And these 2 times must be in 2 separate documents. It's not one document 2 times. These words actually, because we have said like those occurring in one document only, even 2 times, 3 times, 4 times, it will be removed. Okay, so this is the one that, yeah, those words actually, it should appear in 2 separate documents. Can you share your word list as well? Maybe top 10, yeah, in the chat box, just to counter check, yeah, whether you got the same list or similar list, because we have a slightly different numbers, yeah, of the words. Maybe Anisa and Muna, you can share the top 10 word list based on the new DTM. Okay. Okay. Oh, you still got goat, huh? Hmm. Goat 18. Okay. Goat was in my previous list. In my goat 24. What about Anisa? I mean, yeah, I want to take a look. So Afiq, okay, Afiq got top 6. I wonder, Monas, why your goat is still there. Just curious. Unless you have done something. Okay, goat appears. Because goat, okay lah. If you follow the original documents, it appears in 9 documents. It appears in 9 documents, unless you have removed one of it in somewhere lah. Yeah, maybe lah. I'm not sure. Maybe you have removed like one of the goat from one of the documents. But anyway, yeah, later you can check lah. Just trace back. Okay. But I think Afiq's one, yeah, Afiq's one quite tally. Yeah. Just that he got the maybe one or two words difference, because just now I think I removed the additional stop words. Okay, so let's continue. Okay. Okay, so term frequency. Okay, this one we have done. Solutions. Okay. So there's okay, there's one more analysis that you can actually do to look at the associated words. Okay, this is just to look at if you have one word, what are the words that has been actually used together in the same document? Yeah. So the find associations functions, you can use that to discover a set of neighboring words, yeah, that often used together with a particular word, because that word may not be for example, if you have farm, right? Yeah, farm is probably pick up was can be detected lah during the first round because of its popularity of the keywords, the rank and so forth. Okay, but then from these main seed words, there could be some important keywords that has been always mentioned together. So those words could be useful as well because they are used together with farm. Okay, yeah. So this is one way to detect the second set of words by giving it like one seed word, and then we find the neighbors. Okay. So you can try out find associations, but there's a threshold that you can set lah. How many what are the words that we should shortlist? Okay, so the threshold is basically calculating the correlations between the two the pair of words. For example, like between farm and durian, farm and sanan, farm and tour, and so forth. Each pair it will have its scoring. Okay, the score details is yeah, this one. Pearson correlation coefficient calculations. I will not explain this because it's very complex, but I've actually included one example for you to try. If you want to compare the scores, okay, you can use this sample. Yeah, just run it. Yeah, basically this sample is to create a matrix of for example, one word. This word, let's say word 1, right? Okay, word 1 occur with word 2 and 3, and for example, word 1 occur with word 2 in how many documents? Okay, yeah, in like document 6, 5, 4, 3, but not 2 and 1. Okay, so this is for us to actually examine the scoring only. Yeah, because for Pearson correlation score, it's not taking like the ratio percentage. For example, like if you look at like word 1 pairing with word 2, okay, word 1 pairing with let's say word 1 pairing with word 2, it's not just a simple ratio of like 4 out of 5 like this, because we know they pair four times, right? Yeah, it's not 4 out of 5. Yeah, okay, so you can try out this one. Okay. So let's just run this 5 associations. Okay, it's down there. Yeah, this one. So if you can change the word. Maybe I change to milk and see. Yeah. Run. Okay. So milk has 2 correlated words, which is more than 0.6. Maybe I lower it a bit. Just want to see the more words. And run again. So you can see if you lower this score, of course you can get more words lah. Okay. But if you want to use this, right, still I think we need a larger data set, because we only deal with 10 reviews only, very limited. We cannot see the frequent occurrence, the occurred patterns. So you can share the words that you try. Maybe you try other words. Yeah, you can try out to check out other words. Yeah, then can share with us. So we are going to move to the final part, which is the plotting. Okay, the plotting. Yeah. So we will be plotting two different type of charts or graphics. Okay. Okay. The first one is the histogram. Okay, the histogram. Okay. So for the histogram, we will be plotting the terms. Okay, the terms and their frequency. Okay, the terms and the frequency. So the terms is the one that we have actually in the list. Okay, the one that's sorted by you, the previous steps. This list. Okay, and what we need to do is to create the data frames for the vectors. Okay, so we need to have the terms itself and the frequency. Okay. So the package is ggplot2. Okay, ggplot2. Okay, remember to load it before that. And then we can use gg. Okay, so we'll be calling the ggplot functions to plot the histogram. Okay, plot the histogram by inputting the data frame lah. Okay, the word frequency sieve data frames. Okay, so when you input this, we can actually set still the the subset. If you can set whether you only want to show the you only want to plot the one like larger than a certain frequency and so forth. Okay, so the AES is the labeling lah. Okay, the labeling of the histogram. You want to label the y and x-axis. Yeah, and a bit more setting. Okay, this one you can explore the ggplot library, heights and so forth, and the also the angling. Yeah. Okay. So let's take a look at the plotting part. Okay. So don't forget to load the library. Okay. You can grab the whole thing till the end. Okay. So the library, I think ggthemes we no need yet for this one. Yeah. So you can ggplot two. I'm going to group it up here together. Okay, ggplot two. Yeah, remember to load. Sorry. Yeah, this one. Okay, so let's load the package. Okay, loaded. Okay, after that, okay, this is number 9. Okay, create the data frame. Okay, create the data frame. Okay, this one. Okay, after that, yeah, you can do the plotting. So just, yeah, this one you can change lah later, but now we just follow this. We plot the one more than 3 times, okay, 3 times. So the can run and then, okay, can execute this at the same time. Labeling, yeah. So there are a few settings which is different from the slide, like additional settings. I think I put some color here. Yeah, this one can change, can So, okay, you can try this, the first one first. Okay, you can try the first one. See whether you can get the histogram or not. Okay. So if you manage to plot it, can you let me know? Yeah, at the chat box. Maybe just now the status at 4, you can type 4, okay? Number 4. Anna, okay. What about the rest? Okay. What about others? Are you able to try out or do the are you able to follow the steps? Okay, so maybe Milna and Hanim, you can share your output at the Padlet. Okay, you can share your output at the Padlet. Yeah. So okay, where's our Padlet? Here, this one. Okay, you can share the output at the Padlet. Okay. After this, we are going to proceed to plot the word cloud. Okay, we will proceed to plot the word cloud. And I think the other one, the top words list, yeah, that one we can actually project it as the popular mentions lah. Yeah. Okay, let's continue to look at another one. So the word cloud. Okay, so to create the word cloud, we need this word cloud library. And okay, for word cloud library, there's one special settings lah. Okay, according to the documentations. Yeah, for you to set seeds with a certain number. So the purpose is for the consistency of the look, but you can try without setting the seeds. It also works. Yeah. Okay. So for word cloud, you can input the terms, okay, and the frequency directly without the data frame. Okay, and this scale is the scale of your the cloud. Okay, this is the recommended one. Okay, this is the recommended scale. Okay. Yeah, you can try other scale also, but yeah, these two settings, if I remember correctly, is the recommended one. Okay, so you should be seeing output like this. Okay, you should be seeing output like this. So the next part is the cloud. Okay. So remember to load the package. Okay, word cloud. I'm going to put it up here. So remember to load. If you check, okay, just run this. Basically, okay, we got two lists. You can try with the full list or the reduced. TR is the one reduced list, the one with the term reductions. Okay, you can just plot for two lists as well. Okay, I'm going to set the seeds, and yeah, you can plot your first cloud. Okay, line 203. This one. Okay, yeah, just click on it. So for the word cloud plotting, you can also set the minimum frequency. So if you want to display more words, so you just set the lower, okay, the lower frequency. Yeah. So this one, it will display the words as long as for 3 and above, those occurring 3 and above. Okay, and then, okay, let me see. Okay, this is the one with the color. This one frequency equals 2. You got more words. Okay, there's an issue with the package. I think it will. It has been cut off. Yeah. Muna, yours is what? Figure margin too large. For which one? The first one or the second one? Maybe you can share the line that you have executed. Okay, if for the crop off, this one, some part has been not visible. The
It come out the blue color, and then below that there is written error in plot. Figure
Oh,
margins too much.
so this is the first one, right? This is the first one,
Yeah,
margin.
after the set seed.
Hmm. Do you set it?
Yeah,
You can set it,
I
right? I
already
think so.
set seed.
Figure margin too large. Too large. But you're running the same. Can you maybe just double check your list and see? Is this the
Which one?
is the your frequent this one, this list? Yeah. Is there a list there? Yeah.
Yeah,
Just
yeah.
make sure.
First the frequent, and then
Dot
frequent.tr.
TR.
Mm.
So there's a list, right?
Yeah, there is a list. Animal 6, delicious 3.
Okay. So the list is the same.
Yeah.
Limit the words. Did you loaded the word cloud package already?
Yes.
Okay. You loaded the okay.
Just now after I load the cloud package, and then it written loading required package R color brewer. Correct, right?
Loading. Should be correct.
Ah.
Okay. Mine maybe because was loaded already.
Okay.
So you loaded the word cloud package, So what about the second cloud? Can you try the second one?
Got second cloud.
No, I
Which
mean
one?
this cloud.
The following one.
The
Okay.
following
I
one.
try first.
Want to just see whether the scale is an issue or not. Yeah, maybe I also put the okay, never mind. My is okay. I just leave it. Yeah.
The second cloud, the plots coming out, but also there is warning message.
Oh, the plot, but the first one got is there a plot?
No, the first one don't have plot. The second one got plot, but there is warning message.
Should not be fit on the page. I think yours is yeah, why
Too big.
too big, but this should be because this is the recommended scale. Maybe can you try to adjust the scale a little bit?
Okay, I try
How come
first.
yours is too big? I think the word list should be the same.
Yeah.
Scale.
Because just now my histogram already same with yours.
Because like for my case, it was crop, yeah, too big. And then if you see here, let's say as save as, right, export, save as image. You see, it was like crop, and what I can do to that. Okay, I found a way to do it. Is you can review. You can actually make it bigger, lah. Okay, let me try. Not this one. How do I do it already? Wait, I remember export and then I okay, let me try again. Update. Yeah, just to
When are the farm?
this is not so nice. Okay, let me update. I have to adjust the height and width to reveal the plots. Yeah, that is one solution that I found. Yeah. Okay. Oh, where is it? So it's gone also. So it cannot show. Probably it's bigger than that size. Okay. So anyway, there's you have to adjust lah. Aniza, you got issue in displaying your histogram. Okay. Do you have any error message? Do you get any error message? You loaded the you loaded the ggplot, right? Yeah. Did you load? Have you loaded the ggplot? Hmm. Okay. Second thing that you can do is just to crayon not found. One thing that you can do is to counter check the codes. But if you just copy over, then should be okay lah. Yeah. Another thing that you can check is I don't think we need this GG Teams. Let me see. Last time what I used this. I don't think we need the GG Teams. But you can try load it and see. It could be for the other sections. I can't remember exactly, but there's one library called GG Teams. I don't think we need this. Okay, let me check whether my GG Team is being loaded. Just a moment. It's not loaded. I think we don't need. Oh, wait. I think I know why already. Okay, counter check the spelling. This one, the occurrences and the spelling over here. Yeah. Can you double check this one and this one? Let me go back to this. Yeah. You double check the spelling because in my slide there's a spelling error, but if you just get from the code should be correct. Okay, the spelling, the R, yeah, you double check these two. Okay, so for Muna, you try to maybe try to rescale the yeah, you try to change the skill. I don't think that's that skill should be okay. Yeah, but you try to change the skill and see. Yeah.
Okay.
Yeah. And then if anything, you just snap and then paste at the Padlet. I'll take a look later. Okay. Okay, there's one more actually, the cloud package. Okay, this one is word cloud tool. Okay. word cloud 2, yeah, this one. You can also try out. This another word cloud lah. But this cloud package, right, it's for the use of when we want to load it over the for example, the front end lah. Yeah, so there's actually a interactive cloud. So there's another package that you can test. The cloud 2 run. Word cloud 2. Okay, for word cloud 2, you can the input is a data frame. Okay, the input is data frame. You can actually use the same data frame that you have created for the histogram. Okay, just run it. So this is another one that is interactive one. So this is the one that actually, if you are building our a front end dashboard, yeah, we can use this. And the stars, okay, you can have the stars one or other shapes. Okay. So there's okay, one more. Okay, this is the height. Okay, the last part of this this slide will be the dendrogram. Okay, dendrogram is actually another plot you can explore, but actually it's not so suitable to be used for the text analytics front end for end user. This is, I think, for the data scientist owns analysis only, because it's going to show you like clusters of the it's a clusters hierarchical clusters diagrams. Yeah, so there the reference is here. You may follow this. Okay, just show you here is at the end here. Okay, so this one is additional. You can follow this. Yeah, it's a cluster view of your DTM. Okay, or TDM. Okay, so that's there are two versions there. You can either use this to view the terms clusters, how the terms are actually used together, and also you can also view the how the documents occurs together. But of course, for documents, because our documents only 10, yeah, it's plotting the document view is that not interesting. Yeah, this shows the cluster, the terms cluster view. But again, this output is not so useful for front end user. Yeah, but it's good for us to analyze, to look at the terms that occurs together. Okay, so this is a cluster, a plot that actually based on the idea of clustering. Okay, clustering is an unsupervised method for us to find like similarities or to discover groupings. So it's unsupervised. That means we no need to label the data. So just based on the documents and the co-occurrence similarity distance, okay, distance measure, we can actually see what are the terms that actually occurs together more often. Yeah, for this case. Okay. So you can actually follow the steps and drop these clusters. Okay. So do you have any questions up to now? Yeah. Because I'm going to show you one more part about how to load the data from a CSV file. Yeah. Any question before I show you the another code and another scripts? Okay, so if no, let me just show you another scripts that I have shared. Okay, So actually you have gone through the whole process, okay, from data loading to the plots. Okay, so once you are familiar with this pipeline, right, the whole process, you can easily actually bring in other things like. So just now we have loaded the data using text, using the txt file. Okay, so what you can do more is to, okay, not this one. Okay, there's a script called text Excel. Okay, yeah, but this is the input is CSV. Yeah, you can actually load the data from CSV. Okay, so just ignore these two. What you can do is to read. Okay, yeah. So instead of creating the corpus from the folder, firstly you have to read the CSV first. Okay, read.csv. So you can read the CSV. The CSV need to has one format lah. I will show you the format. So you read the CSV, and this is the path to your CSV file. Okay, so you can something.csv. Header is true, and you can read it as a review data. Okay, create a data frame for it. Yeah. So when you create the corpus object, you just call it. Yeah, you just refer to the data frame. Okay. Yeah, you just refer to the data frame. So let's say, okay, we go to the CSV file. Yeah, maybe this one. Okay, example. So your CSV file need to have this format. Okay, you need to have document underscore ID. So this is your document. You can have 1, 2, 3, 4, 5, and 6, and so forth. Okay, and you can. Okay, no, this one I wrap text so they can read. Yeah. And then the second column will be your text column. Okay, so this is the place where you paste the review. Okay, so you can have the review here. This one is about one movie, Black Adam. So you can paste your review over here. Okay, yeah, you can collect your review and paste it like this. Okay. Similarly, later when you yeah, actually I would like you to try out the tourism spots for that you have shared in the morning. So you just collect a few review, maybe 10 or 20. Yeah, so you can either put it in text, separate text file, or you can use this. Okay, you can try out this. Yeah, put them in a CSV file, and then try to rerun the whole process. Yeah, because I'm sure your review will be very different and probably more complex compared to the one that we are actually we have tried out today. Yeah, so you will see maybe other types of cleaning need to be done. There are steps that need to be improved. So over there, you can actually improvise your code. Okay, but the format of the CSV, just remember you need to have this header. Okay, you need to have text and document underscore ID. So review goes here. Okay. You can also run this, yeah, the Black Adam text. This is what I said, like if you look at the review text of movie, it's very long. And it talks about like it has a mix of the sentiments and also it has the narrative about the story. Yeah. So we have to understand what people want to know about this text. Is it about like what the who is the villain, who is the hero? or is the movie good or not, interesting or not. Yeah, so this is something that we is very different from one domain to another domain. Yeah. Okay. So you can try to create the CSV file. Okay, this is okay, one thing. I will also show you, if you have some time and want to explore, show you one more. Okay, the ngram one. Yeah. Okay. This one is, you can get it from the eLearn as well. The main difference, okay, the interesting part is reprocessing. Yeah, everything is same. It's when you create the DTM, okay? Yeah. Or over here is TDM lah. Okay, you can actually run this and try to inspect. Okay. So the idea is whenever you create DTM or TDM is just the orientations. Yeah, this is from TM package as well. You can also transpose from one to another. Okay. So the idea is, when you create the document term matrix or term document matrix, we're actually controlling the terms. You can control the tokenizer. Okay. Yeah, by telling it that just now we didn't control, so we get one word token. So now what you can do is you can apply the bigram or trigram tokenizer. Okay, you can apply the bigram or trigram tokenizer that will give you the output, which is the 2 words or 3 words. Okay, probably I show you the, okay, maybe I can inspect one. Just run. Yeah. Okay. Because I have already run the scripts before, so yeah, this will actually shows you the terms. Okay, the terms. So this is the bigram, and you can also see the trigram list. Yeah, the trigram list. Okay. So if you compare to a single word, this will actually, you get 2 words. Yeah, you get 2 words. Yeah. So you can explore on this part. So basically, you are going to need to declare or create the tokenizer. So these 2 lines is for you to create the tokenizer. Okay, you are going to create you need to create the bigram tokenizer. Is a functions, and also the trigram tokenizer, also a functions. Yeah. So when you create your DTM, just apply this. Okay, apply this control. Okay. Yeah, then you will get the terms as 2 words or 3 words. Okay. So a few things for you to try lah. Okay, the loading using the Excel, the CSV file, try out bigram, trigram tokens, collect your own data. Okay, collect your own data set and see what is the challenge in the new data set. Okay, so yeah, I would like to open for questions. Yeah, because before we end the sessions, any questions that you want to ask?
Doctor, for example, like just now when
Sorry.
we already run, for example, we remove space, so we cannot undo it again.
Oh, okay. Remove space means the which one? The hyphen to space,
The
is it?
earlier part. Just example, I mean, because we
Oh,
run all the functions step by step, like if I miss one step, then I want to undo. Is it possible or not?
so far cannot undo, but you can reload lah. Reload and rerun the first few steps.
Reload means reopen again
Uh,
and run
you
again.
yes, yeah, you
Oh,
reload again lah. Yeah.
oh, okay,
So
okay.
yeah, just reload the data. Yeah, just reload. Here lor, just reload the corpus again lor, and then replace with with the clean one. I mean the original one lah. Yeah. So sometimes because now the data set is very small, so it's fast. If it's big, if you have certain process, maybe you think it's mature already, then you want to move on to the next step, right? The next step is a testing step. So maybe you can actually duplicate you just duplicate the your objects yeah, so that you don't have to rerun every time. So you can at some point you feel like okay, now up to this pre-processing step, I'm okay. This is the one that I already got right, I already tested. So, but the next few step you are not sure, so you can actually duplicate it yeah, for testing yeah. But in case you want to, in case because normally we are testing it from time to time, we always you can reload from the beginning yeah, load and then replace. Okay, so looking forward to your word cloud or histogram for these tourism spots. Okay, there are many sharing this morning. Didn't manage to go through it properly yet. But some of it maybe we don't have. Yeah, this one Langkawi, Dayang Bunting should have. Yeah, there the Lord Jambada, not sure. You can try to find. This one is in the. This is in Kuantan, right? This place. This okay. The rest I think should be quite okay. If not, you can change to other places. Okay, so we got the sharing. Oh, if set to 450, no picture coming out. Yeah, just now mine also disappear. Just now I set bigger when it goes beyond one number, there's a feature save as. You try to save as and view and see. Okay, this one. Okay, the sparsity is 66. Actually, I think for the sparsity, we don't have one exact answer. Yeah, which one is acceptable? But our goal is to have less lah. Yeah, but actually, when we look at the sparsity of 84, it's considered it is considered not high already. Next week you will get a shock because the sparsity is very, very high. Yeah, but still we are building the model from that data set. Yeah, basically for these two numbers, because our data set is very small. Yeah, this is considered low. But I guess what you can do is you can do experiments. The thing that we are doing for today, I don't think we can really evaluate the sparsity. But for the next week next week module, when we check out the how to build the classifiers, you can actually try out the model using a different using the input with different sparsity level. Yeah, then you can compare. Okay. Yeah, so I think in the end, just comparison lah. Yeah, if the high dimensions matrix goes in, and then what we are going to get, what is the accuracy? If the lower dimensions lower dimensions one, is it going to improve the model predictions? Yeah, that one I think we can somehow measure between the high and the low sparsity. Right. Okay, any more questions? Okay, if no more, maybe I just go through a bit about what is going to happen next week. There's a preparation for next week, because next week we are going to look at two things. One is we continue R for text classifications, and then I'm going to show you one interesting platform for text discovery or text search. Okay, but for this platform, you will need to have JDK. Okay, JDK. So JDK takes time to set up. So you need to install first your JDK. Solar is pretty straightforward, because Solar, you just need to download the folder. Okay, the zip is a folder. Yeah, so you can download, at least get ready the JDK first. Solar, okay, Solar is over here. This site. We will need the one with the .zip binary release. This one, okay. Yeah, this one, we just need this zip file, and you place it somewhere. Okay, just download and put aside. Yeah, we just unzip it, then you can use already. Yeah, so you can download this JDK, and then install JDK. Solar, no need to install, just download. Yeah, then configuration wise, I think we need to look at it together next week. Yeah. So basically, this is a platform. Okay, this is a platform for us to perform text indexing and text search. Okay. So we will look at this. Okay. Right. So just to make sure, check again. Have you completed your training assessment? Anybody hasn't done that? Yeah, let me know. Yeah, I can extend a bit. Okay, so this one is you just get ready first. Okay, the two software for next week. Additional package for classifications. That one is quite fast. You can install it next week. All right. Okay. So if no questions, I think we can end the session for today. Okay. Yeah. I'll be here for another few minutes if you want to ask me anything, but I'll just pause the recording first.